All right, we are streaming at 2,680 kilobits per second. So this is stream 14, doing a series of streams where I'm porting a tool that contains a compiler and is used to process binary data. Very similar to a tool you might have heard of called Wireshark. It's protocol dissectors or data dissectors can take a bunch of bytes and assign meaning to them based off of what it knows about the format of those bytes. So in the same way, you can write a program for my tool that describes data that you want it to parse. So like this would be a GIF file, and you describe it in terms of parts all the way down to the elemental bits, like strings. So here a GIF starts with a header. The header has a signature and a version. So if I can get a terminal, please. So the tool is already written, wrote it like 5 years ago, and you can see its output here. I don't have a GUI for it yet. It's mostly just a command line tool. So processing a GIF file, it can see, yes, the signature is GIF, header is 89A, and the width is 300. So that's looking at a specific file, this lol.gif that we have. All right. So porting this to Rust, because it was written in C 5 years ago, there are 3 parts of it. There's the lexer, which will do this, turns the input program into a sequence of tokens. Second part takes that token sequence and matches it against the rules of the language, so the grammar of the language. And that looks like this. So like a statement has a format and then an ID, optionally, arguments, and then like an optional ID is either nothing or an identifier. So we're using a crate called Lollerpop, which allows me to describe the grammar rules in Bacchus-Nor form, where the when rules are reduced, we actually execute arbitrary Rust code to form the value associated with that reduced rule. Cool. All right. I had so many bots in the chat before I started. And I did a little experiment today. I banned them all. And I put in a mod note saying that this is a suspected bot. So it's not that I don't like bots. I have my own bot. It can respond to some commands, like the today command. Problem I have with them is when the bots are using named accounts and they're in here like doing nothing. So, and not following. So I'm okay if your bot follows me and behaves itself. I'm okay if you join chat with an anonymous connection, which is what my bot does, so that no, not my bot, but what some of the tools that I make will do, so they don't show up as chatters. Because the thing I don't like is it artificially inflates the view count. I think the view count should always be actual humans actually viewing and not include bots. So it's a little experiment to see what's going on. And like I just noticed my bot noticed that pretty much every bot that I banned left the channel. But I don't know if that's because they're banned and they don't show up in the viewer list anymore, or if they voluntarily left. Either way, I'm kind of happy about that because that cleans up the viewer list and it shows me like who actually is watching, which isn't very many people, but that's okay. This is not like a normal time for me to stream. All right, so where I left off yesterday, I was this is the old grammar from the C version of the tool where I used Bison, and we're going to a Rust version that uses Lollipop, and I had done two kinds of statements, and then the third kind of statement in my list was the if statement. Here's what the old part and ignore specs used to be, and this is what they are now. So the conditional logic, if parentheses, and then we had a little discussion in chat last night that we probably don't need these parentheses anymore because this left brace is probably enough of a delimiter along with if to delimit the expression, and then just the parentheses are unnecessary. And if we're porting to Rust, where not only are these unnecessary, but you get a warning from Clippy if you have them, maybe in the spirit of that, we'll revise my grammar to remove them. But I'm going to try to do a straight port and not try to do too many design decisions. I've already done a few, and I'm sort of pushing it when I do that because it's going to be an unequal comparison to compare before and after of the two implementations, especially if I'm going to do like timing analysis and see which one's faster. If it's unfair if I strip stuff out of the Rust version because it might artificially make it give it an advantage it shouldn't have had. Okay, so in here I have my unit tests here, right? And that's not the unit tests. The unit tests are in another file called statement. Here we go. So there's our test case for the ignore. There's the test case for part. So basically, we use the test case crate to form our list of input tokens and then how that should parse as, in this case, a part statement. And here's another list of tokens, and that parses as an ignore statement. And that generates variations of this test runner, which takes the input and attaches arbitrary locations to it, and then runs it through the statement parser and compares it to the expected output. Hey there, I play poker badly. You are not a bot. Hello, non-bot. How are you today? I'm doing some like esoteric crap today, so my apologies if this is like really hard to understand and way over people's heads. So making a compiler for a specialized language that describes data. So like this is the composition of a GIF file, right? You know, those lovely little files that you might have seen that do things like that, right? To a computer, it looks like this. And the tool I'm working on basically pulls apart every single byte of that and describes what it means based on the format description in the language that I'm making. Make sense? So like a GIF starts with a header, and a header starts with a signature and a version. So there's that signature and version, and it says that the whole header is 6 bytes long. And we even have little checks to make sure the signature is correct, so that if we give it a file that's not a GIF or it's broken in some way, we would stop at that point. It's a GIF parser if we use this program as its input, but this program is compiled by the tool just in time. So if I were to give it a different FMT file like JPEG, and then it would be a JPEG parser. Yes, that's a great question. I play Poker Valley. Why the heck am I doing this? So it's rooted in the fact that when I was learning file formats years ago for the last company I worked with, there wasn't a really good viewer tool for some of the newer formats. Like at the time, like this was like, I don't know, 10, 15 years ago, they were coming up with the MP4 file format, right? So you might recognize MP4. It's what a lot of movies are saved as. So it was a new format, and we were like trying to help implement the parser and the generator for the format. And I didn't have any good tools that knew the format. So I'm like, I'll just write a tool. And when I'm writing the tool, I'm like, you know, it'd be really useful if the tool wasn't just hard coded to understand MP4, but if you could like adjust it and make it like understand other formats too. And then I'm like, what if like we could describe the format similar to how they describe it in the specification? The international standard for MP4 uses like a way similar to this to describe how MP4 is formatted. I'm like, it'd be even cooler if I could just like do copy paste from the standard into the tool, and then now the tool just knows the standard and I don't have to actually code it. I never got to that point, but I got pretty close in that I could just put the standard on one half of my screen and then just kind of like make a copy of it on the right and like start to like tweak it a little bit into more like what this looks like. And it became really useful for learning the file format and also for diagnosing issues. Like if we wrote a bad MP4, I could load it up in the tool, and the tool would kind of pinpoint where the format breaks down. It's a programming language for data rather than code. Does that make sense? So like this doesn't generate code. This is used to understand data. So the closest parallel I could find was in Wireshark, you have these things called data dissectors that take the raw bytes of a packet that you click on and then interpret what it means. So a schema validator also is what you could call it. I like to think of it as an analysis tool. So it'll take data and analyze it and tell you what it means. And if there's something that doesn't match what the standard says it should be, then you could flag it as an error. So if like, for example, if you told the tool that this is how a GIF is formatted, and you gave it a GIF file like this, and if it didn't start in GIF 89A, then my tool would flag it as an error because I have conditional logic to check for it, right? We parse the first 24 bits as a string signature, and we actually compare it to what it should be, and we stop parsing with an error. Or we could continue parsing and just say that, hey, that signature is bad, and like maybe mark it in red. So in that way, it sort of is a schema validator. LSP for data? Yeah, exactly. It's parsing, it's understanding and assigning like insight into the bytes. Just like, that's why I keep coming back to the Wireshark example, because that's exactly what this is. If you clicked on address resolution protocol in the packet, it'll highlight exactly these bytes. And so you're like, oh, okay, that part of the packet is the ARP. And like the bytes that came before are the lower level protocols like Ethernet and the wire, the frame on the wire. And then like the bytes after it are whatever is on top of ARP. Probably isn't any, and this looks like padding to me, but you get the idea. So it's not to replace or do a better job than other specialized tools. Like there's like some editors out there, like 010 editor is one I've heard of that Strager was using. I was going to look this up. 010 editor. It's like a hex editor that understands the data. Yeah, like this. See that? It will highlight certain things and you can click on them or something and it shows you what it means. So I'm not meaning to replace this. It's mostly like a tool I'm making for fun that it's similar to these other things like binary editors, the smart binary editors in Wireshark and all that. So yeah, it gives me an excuse to work with compilers. And how often do I get to work with a compiler, right? So my tool has to compile this into basically a data tree in memory that it then walks in order along with the actual data here in order to come to a conclusion about what it is that we're looking at, right? And then eventually I want to like make this the engine for a GUI that it might look like 010 editor, or it might look like Wireshark, or it might look like whatever it's going to evolve into that I think is cool. And then I wouldn't like use it for any particular format. I would just have it be available for when I'm working on other projects if they're working with binary data and I like have some like maybe a debugging need that I want to like look for a problem in like how the files that my project is dealing with are encoded. I can use this tool. It would be like a helpful debug tool. And like I said before, if I'm learning a new file format, I might augment my learning by trying to write in my language what that new format is, and then just use the tool as a way to like confirm that I understand it. Like if my tool can parse a format that I'm learning, then that means it's a validation that I understand the format. And then I could like use it to look at interesting bits of the file that I'm learning the format for. Yeah, you get the idea. I'm over presenting, but that's okay. That's what I always do. So like this if statement here, the tool I'm working on needs to be able to understand that this is reduced to one node in the data structure, then when we hit it, it has to, instead of parsing some bits, it has to look at something we've already parsed and evaluate, was it 3B hex? And then if so, it should say that the next statement is break. Otherwise, it should jump out and say the next statement is to parse a data block. Well, thank you, young Steve-O. So yeah, I was talking about this yesterday. I'm working on this, like I consider it like an area of growth for me, in that when I'm streaming, which I do mostly because I value your feedback, and I also think some people might find it interesting, or maybe just like the sound of my voice while you're working, co-working, so to speak. That's all good. But one thing I do, which is I want to get better at, is I'll over-explain because there's no like body language feedback. Like it's not like people are nodding, saying that they get me. And so I err on the side of like re-explaining and over-explaining and just throwing a lot of words out there. And I think the only way I'm gonna get better at that is I should kind of like assume that you're smarter than like I jump to the conclusion. And like, oh yeah, they'll get it if I just say it very briefly, you'll get it, and then I'll move on. And if you don't get it, feel free to write in chat that, hey, could you explain that a little bit more? And then I'll be very happily switch back to the over-explaining mode. Okay, so porting this to Rust, right? I need to express this in what Lollipop does. And if I'm trying to make sure that I'm doing this in a test-driven development way, it means I want to write the test first. So let's do that. And I'm gonna copy the test case from the previous kind of statement, which was ignore, and then we're just going to rename it to an if. And I know from the past week that we can't name it any reserved word in Rust, so I'll put an underscore in front. Very dangerous to overestimate my intelligence. Well, that's okay. You'll let me know if I need to give you more information, right? Sometimes people don't even really need to know. They just kind of think it's cool to look at. You appreciate my explanations? That's good. Don't think you need to get better at it if you were at a conference while your audience is known. You could wonder if you're over-explaining, but literally anyone could walk it on Twitch. Yeah, so there is one definite disadvantage to doing this on Twitch versus like a conference, and that's people are constantly coming and going, and so no matter how many times I'm going to go over like what it is I'm doing and what this all means, inevitably someone like an hour or half an hour from now is going to come into chat and say, could you explain what you're doing? And I'm like, okay, well, I'll try to give an even shorter recap of what I'm doing. But like, what was it, yesterday? I was doing it so many times, I started to think, I should probably record like, or take a clip of the best explanation that I've managed to do for what I'm doing and put it in YouTube, and then have my bot link to it. And then I could have like a recap command, and then it would just spit out a URL saying, hey, this is like a 30-second explanation of what Rhyme is doing. Go watch that and come back. And then it wouldn't be such a repetitious, annoying thing for people who have been watching for a while. I think I might do that. It's hard to say what I'm doing in terms of like a bot responding with a single line. So like my best attempts have been like project, where it says I'm resurrecting an old tool for parsing binary files, but that doesn't really explain it well enough, right? So then I added commands like if people see that I'm using a file that ends in lollipop, they might type lollipop, and then it says, oh, it's a Rust parser generator framework, and there's a link. So people who are willing to like guess or use the like there's a DSL in the title for the stream today, they could like get some more information. But turns out there are a lot more lurkers and people hesitant to type up in chat, and I feel bad. It's like the bot could actually explain a little bit of what I'm doing, but no one really uses it much. Totally derailing the stream. Nah, you're not. It's me derailing the stream. Okay, I'll get back to work. I'm just thinking like how to take the next step in improving this. So an if statement, right? So we have a reserved word if And do we need to have a comment here? It's sort of self-explanatory. If, and then we have, for now, we have the left parentheses, and then let's indent the rest of it so because it's sort of important, except for that line, because it will be delimited. So I want to kind of make it look at a glance like an if statement. So like this will be a right paren and followed immediately by a brace, right? A left brace. Brace. And then some statements. So we'll just have like, I don't know what we'll have here, an empty statement. The smallest statement I can come up with is another format and a semi. That's the smallest statement we could do. And then terminate again with a token R brace. And I think we don't need a semicolon at the end of that, if I did this right. Oh, we could have conditionals, which is, I think that's else, and else if. Yeah, we could have no conditionals, we can have an else if, or we can have an else, and then an else if can have another conditional, so it's like you can chain them together. So I should have a test case for just the if. I should have one with an if, and then an else, and then I should have an if, else. Or maybe just an if, else if. Because if I already test op conditionals once, I don't need to test it again, right? Okay, and then what's in the parentheses is really just an expression. So I'll just pick the smallest expression I can think of because we already have the expressions tested elsewhere, right? So there's the smallest condition we can pick. So if left parentheses, some expression, right parentheses, left brace, and then some statement, right brace. Okay, so then let's reduce that to what this should be. Should be statement. Do I use the word if or conditional? I think it is conditional, but do I use that anywhere else? What if I just call that an if statement? Oh, because an else if is also a conditional. And so is an else. But that's only, I think I didn't really need to reuse that type because an else just has substatements. An else if has a, it should have an expression somewhere. Wait, where, the expression is missing. Oh no, there it is. There's an arguments to the statement conditional. I think if and else if could use the same type because they both look the same, right? They all have a next and they all have arguments, but then the else doesn't. So one could be like this the else could just be like just a group of statements, and this one could be conditional, and conditional will have the statements with arguments, which would be the expression to evaluate, right? And then instead of having this linked list, I can just put the entire thing in a vector, and the vector is like the chain of conditionals that we evaluate until we find one that matches. And the else will have to tag along at the end somewhere. I'm trying to think how I'm going to form this in the statement. I should probably just write it here, right? So if we have like conditional, like I was just saying, then I'd probably have the condition, which is an expression. I might have to box that because the statement containing it, no, this is not recursive. An expression can't contain in a statement. Okay, so then this would be statements. Vec statement. Actually, if I wanted to make a chain, wouldn't I want to have a vector of these? Hey there, Endorn. How are you doing? So, Endorn, what did you think about the partial eclipse today? For you, it would be this evening. You can finally watch a stream, yes, because we're in an EU-friendly time now. You're probably too far away from the path of the eclipse to have seen anything, right? I had some friends who actually took a trip out to like several states away from where I live, like maybe 1,000 miles away, just so that they'd be in the path of the eclipse, so that they would see it as a ring of fire around the moon. Didn't know there was a partial eclipse. Well, that's okay. There's like one every year. Next year is supposed to be like a total eclipse if you're in the path of it, which would be pretty cool. We might actually go out and see that. Okay, I'm trying to think, how would I form a chain here with the C version of this? What I did is I just made this a linked list. I'm actually thinking that the conditional should be its own type, and the conditional variant of a statement would have vec conditional in it, like this. For the ifs and the else ifs, but then we need like the else. So what if I, this is bad, but not giving them names, what if I had like an else? The else would just be a statement, right? Yeah, I'm gonna have to give these names because I'm not gonna remember what these mean if I make it a tuple like that. So this is the idea, right? We would have a struct conditional with the condition and statements in it. And an else is just something without a condition. Makes me want to kind of have a type for that. Like statement with an S. Plural statements would be a vec of statement. Maybe I don't need that. Yeah, so anyway, I think it's best to make this be a structural type variant and give these names. So this would be like the if, this would be like the chain, and then this would be the else, which we can't use. How about like this would be the alternative? That alternative is not a good name either. So it's like the ifs. This is like if and else if, and then the else at the end, right? So it's not alt, it's like otherwise. Otherwise is just another word for else. Actually, I could just keep these. These will remind me what they mean. Is chain the right name though? And what's the... Oh, yeah, it's not going to like that type until I derive debug and partial equal for it. Is chain a good name? Putting structs in enums? Yeah, you can totally do that. That's one of the cool things about Rust. You could do this in C too. So the C equivalent of an enum is... a C equivalent of a Rust enum is the combination of a union with an enum. And the enum is just used to pick the field of the union that you would want to use. But a field of a union can be itself a structure. So you might have this in C would be a union with 3 fields in it, and all 3 of them would be structural fields. Perfectly legit. The advantage of Rust is the union and the enum are combined together as one enum. Also, the fields of this combined type can have constructors, whereas in C you can't, because there's no syntax for it, and there's no way for the language to know, the runtime to know which values of the union are constructed or not. You know by convention having that discriminator enum next to it, but the compiler doesn't know that. In Rust, they're combined, so the compiler and the runtime do know which of these is valid, right? Because the value can only be one of the three variants. So it's actually pretty cool, but the fact that it's a structure is not new. I don't know if chain's the right name for this. And it still has a problem here. What is that? Private. Oh, we need to make it public. Which means I probably need to make these public too. Oh yeah, thank you. You're running my bot's commands. Solved a similar issue with your own toy language of making if, else if, and else be expressions rather than statements. They just eval the left side of the AST. So you can do it lots of different ways. In the C code, it just formed a chain, and I actually call it chain at some point. Maybe not here. Maybe it was in the if itself. I didn't call it chain here either. I just called it op conditionals. Next alt, right? Next alternative. Actually, then what if I call it alternatives? I could use the full name or I could use alts. Actually, that kind of works. So a conditional has a condition and statements, and an otherwise is just statements. Any advice for someone who wants to start in cybersecurity without a degree? I don't have any, but maybe someone in chat does. I really don't know anything about cybersecurity. I think we'll go with this. So going back to the unit test, that means this is going to be a statement conditional. I don't cheat and look at it. Alternatives and otherwise. This is a vector, right? Okay, and then that is it for that. And then I didn't delete this yet because I'm going to reuse some of it. Like this expression goes into the first alternative, right? So that's a conditional. I'm waiting for the pop-up. Is it not going to allow me to import this? Maybe not. How come my back and forward buttons aren't working? Back, forward. Okay, now it's working. Weird. Okay. I think because this has too many syntax errors, it's throwing a fit. What if I just comment this stuff out? What's wrong with this? Oh, there's a comma. There shouldn't be a comma there. There we go. Okay, now it will let me maybe see. Yeah, I had this problem yesterday. The quick fix to import is not available, but I found a workaround, which is to type it, wait for the pop up. Oh, except for it failed. Bummer. There it goes, the pop-up, right? And then hit enter, and then I can save it. And then the thing will have fill structure fields, and then we're good to go. Yeah, my editor is a little winging out a little bit. I think because we're in the midst of a pretty complicated macro. Okay, conditional, right? The condition is, here's where I wanted this expression, literal integer, because that's our condition, right? And then the statements is itself a vector. And then it's really just a part statement. So we'll steal from the other test, which made a part statement. Only ours is going to be a lot simpler. It's going to have no arguments, no bound, format is bar, so we keep that. Interp is none. Look ahead is false. L value is none. Name is none. Cool. So here's an if statement. Basically, if 42, then we have a bar. Otherwise, nothing. And there's no else ifs because there's only one conditional. All right, so let me write that grammar rule and then we can test this. Wait, why did that have a oh, okay, there we go. I'm wondering if I should move conditional out. I think I should. There should be like a file called conditional. There we go. And then we'll move conditional out to it. Trying to like prevent my source files from getting too big. I am trying to like break them up into small files. So in the lib, we would need to do mod conditional. And then in conditional, we got to import expression and statement. And then statement, we have to import conditional. Actually, we moved it so I can do a little trick here. I can just make that conditional, delete that one, and then delete that one, save. And we're all good. Okay, so then the grammar rule. Oh, no, I have another error. I have to import. Okay, grammar rule. Here we go. It's if L paren, and then the condition, right? Forget what I called it. Condition. That's what I called it. Yep, condition. So C for condition, and that is an expression. And then R paren. And then L bracket, brace, right? Brace. And then statements. So S for statements. Oh, I don't think I have grammar for statements. I should add that. R brace. And we'll just leave it at that, right? That should reduce as a statement conditional. Actually, why type this when I can steal from my own unit test? Here we go. I'm just, don't mind me. I'm just stealing stuff. Paste. Okay, and then alternatives would be a conditional, and the condition is C. Actually, if I name it condition, then I can just say condition, right? Okay, and then same thing here for statements. I could just say statements. And then we have no otherwise, because I haven't written that part of the grammar yet. Let's do this trick where I format it thus so that we can read it without scrolling. Okay, that should be enough for me to run the tests and pass. Let's make sure though. Error, no definition for statements. Oh, I was just saying that. I forgot to do that one, right? So we have statement around here somewhere. Oh, that's what we were in. Statement. So let's make a statements. Which means I probably need to have a unit test for this, right? Okay, we'll do it. It's not too hard though. It's just forming a chain of statements. So that's the grammar rule for that's pretty easy. Hey there, Dr. Padawan. Long time no see. What do statements look like? It's up here somewhere. Statements, right? It's either empty or we have a next in a chain or we right, this is where I found I put in a special rule here so that I could have actually, why did I have a special rule for illegal character after a statement? I don't know why I did this. Let's not put that in there until we know we need it. So then I really need just 2 grammar rules, empty and then forming a chain. Easy, right? So that's the empty rule is this goes to just an empty vector. And then the other form is we have statements or chain. And then we have another statement. And that forms, and then we mark that mutable so we can just say chain dot push s chain. Cool. So run the tests. No addition, definition, developer statements. Statements. Here we go. Statements. If doesn't have a pattern. All the patterns are at the bottom here. So patterns have to be glued to the lexer outputs, the token type, like that. Okay, yeah, we have not imported the word conditional here. I guess that goes at the top because C comes before E. The reason I'm typing manually is because we're not in a Rust file, we're in a lollipop file. So Rust formatter doesn't apply here. Oh, missing a semicolon. Look how helpful these messages are. You missed a semicolon. Add it there. That's because it's in the Rust code. By the way, did you notice something odd about that? Scroll up so you can see it again. Did you notice that is actually not this grammar.lollipop, but it's like line 108,796 in some file we haven't seen? Should I open up Pandora's box and click that? I think I should. This is the Rust file that's generated by lollipop from our grammar, and it's a huge pile of generated Rust code that you cannot read. It's kind of similar to what Bison generates for the C code for its version of the parser. So as mere mortals, we're not meant to actually read this file. And it's amazing that the editor can actually open it, being over 100,000 lines of Rust code. We're not meant to look at this file as mere mortals. We're supposed to look at the input that generated that output, which is the lollipop file. But interestingly enough, when we get errors, it's going to be that the Rust compiler found the error, and so it's going to refer to that not meant to be read by humans generated Rust file. But if something like this, it's like, oh, well, I know where that is. That happens to be there. I can still figure out that I needed a semicolon there. A couple of things that would help, and I think Bison did this, is if lollipop would record the original line number and file that it came from. Like, this came from grammar.lollipop line 22. And then it could maybe report the correct file name and then actually have a 22 here rather than 108,796. That would be the ultimate. Maybe there is a feature request for lollipop for that. If not, I think there should be. Shouldn't you be able to tell the Rust compiler, hey, this code is auto-generated from some other file, so when you have an error, refer it back to the original file, because that's what the human is going to want to look at. Cool. Okay, so our if statements work, but we don't have support for else or else if yet. So yeah, I'm doing this incrementally, right? So I'm like, okay, we have a test for an if. Now let's have a test for an else, and then I'll do the else if last. So with else, then we have an otherwise, right? So let's have an otherwise of some statement in it, right? And we'll just have it say foo or something, because this is a minimal statement, right? And we'll call this the if else. And I don't need an underscore in front anymore because if else is not a reserved word. So yeah, whatever I put here literally becomes the name of the function. So that's why I couldn't name this if, because if is a reserved word, and I'd have to put some weird symbol in front if I wanted to actually name it if. So I decided to just put an underscore in front. Okay, so the tokens to make an else would be after this brace, we have a token else, and then a token L brace, and then another statement followed by another right brace. And this one says foo. Okay, so we're going to run that and it's going to fail because we haven't written the grammar rule for it yet. But it's interesting to see, like, without the grammar rule, what do we get? We get that it's an unrecognized token else. It doesn't know what else means. It'll even tell us it's in the 8th token of our sequence. 1, 2, 3, 4, 5, 6, 7, 8. Well, counting from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So the 8th token else is where it stopped and said it's unrecognized. I don't know what that else means. So to teach it what it means, we go to the grammar and we write an alternate rule. Well, actually, I was going to have it here, right? There's an op conditional. And we have to name that. How did I do this? It was like done in a weird way in the Bison, right? Op conditionals. I think the else was in the linked list here. So I need to do it a little bit more intelligently. I think we'll do it with, we'll do an op else if, and then followed by op else. And this is our otherwise. And this should be like alternatives. Like that, right? So we have if, left paren, some expression, right paren, left brace, some statements, right brace, and then we have the alternatives, which are the else ifs, and then we have the otherwise, which is the op else. So that means I can kind of get rid of that. And then alternatives, what we'll do is make that mutable, and we're going to stick our condition in front. So that's alternatives dot, is there like a push front on a vector? How do you push to the front of a vector in Rust? I guess I could put it on the end and reverse it. So push goes onto the end of a vector, right? And is there a reverse? There isn't a reverse. I thought there was a reverse for a vector. Or is it named something else? Like in place reverse or something? Huh, I don't see it. There's no insert. Oh, there's an insert. Okay, so we'll just insert at index 0. 0 element, right? The element is this. We could put that all in one line, right? I have a feeling that it's going to be more efficient instead of inserting to just push onto the end and then in place reverse the vector, because I think we're building it right associatively this way, right? because we've already built up the op else if, and then we're going to reduce to an if. I guess we could write the grammar a different way. We could have this reduced to something that then there's another rule that this reduction followed by that chains on, like pushes to the end of the conditionals. Would that be better than the way I'm doing it here? Well, let's just play around with this. So this allows me to do this. And then op else if forms a vector of conditionals like this. And then we'll have an op else forms a vector of statements, right? That's the otherwise. So this is going to be, there is either nothing, which reduces to an empty vector, or we have an existing chain. No, there's no chain. It's we have literally the word else. L brace. Well, I'm just going to copy from up here, right? This. And that gets reduced to, actually that just gets reduced to statements. Which if you've noticed, if the statements could be empty, we'll get an empty vector just as if we didn't have the else, which I'm going to allow. So an empty else and the lack of an else mean the same thing. They just get reduced differently. The else if. This might be empty, in which case it's an empty vector again. I don't know why I typed that rather than copy pasting it, but I'm a glutton for punishment. We have else if. Oh, I need the chain in front, right? This is going to be, this part's going to be left associative, right? So we have chain op else if left associative. Else if, and then it's like just like an if, this stuff. Some condition, left brace, yeah, except for we don't do that part yet. So here, the chain will have a push of a conditional, which is this condition statements, and then it's just chain, right? I think I did that right. Let's, I need to introduce else if and else, right? Down here. Else if. I think I'm putting the E in else, the second E in else if. But I should double check that. Yes. Okay. So just go for it. Missing something. What am I missing? Cannot find statements in the scope of the grammar. Oh, because it's not vex statements, it's vex statement. Statement. Alternatives? Alternatives. Again, it would be nice to know what line number that's on, but we could probably find it if we look around carefully. Alternatives. It takes a lot of time to actually build the parser generator tables, I think. Oh, I didn't mark that mutable. Yeah, that would be a problem. Mutate that. Hey, look at that. Passed first try. First try. Okay, we have an if and we have an if-else test, but I don't have an if-else if. So we can just make it very similar to the if-else case, because it's just adding another condition, right? So instead of an else, we'll make it an else if and then another condition followed by a brace. So the condition would be this thing, right? To go there. Indent. And then you can collapse these two. So if 42 bar, else if 67 foo. So we're going to have two conditionals then, right? Two conditionals with the second condition being 67 and its statement having a foo in there, and there is no otherwise because we moved that into the alternatives. So that now we should have 93 tests passed first try. We're waiting on Clippy. We're waiting on you, Clippy. Any day now. There you go. 93 passed first try. Cool. Then I didn't need to do the reversing, but it is sort of a wart on the grammar, right? That I had to do a reverse. Oh, I must have accidentally hit that button. Huh. Minimize. Let's look at that wart. It's a wart. Here. The fact that I had to do this insert. So how might I write the grammar rule so I don't have to do that? I had to do that insert because I made this right associative. To make it left, it would be that this has to reduce first, and then we combine that, right? I think it would be we have to have two rules, right? Wait, this can't just reduce as a statement. It has to reduce as a conditional statement. So we would do something like this. Actually, I can just cut this rule off and then call this pub conditional statement. Is a statement, right? And then I can make two rules where we have that reduces to the alternatives is this a vector with that in it. Like that. And there is no otherwise. So the otherwise would be an empty vector. Okay, and then the other rule would use a left associative rule like this. Some conditional statement which we'll call the mutable chain, followed by an else if. And if I want these to chain, I have to do the else elsewhere, so to speak. Right? So this, now that it's left associative, I can just say push. Okay, here then I would basically merge that rule in, right? I would do this. And paste it here. Right. So it's just basically taking another conditional statement and adding another condition to it. Right. And then the else has to go somewhere else. The otherwise has to go somewhere else. Where would that go? I think that would go in the original statement, right? Which I never wrote here, which was this. Yeah, I think this is where it would go. So it's mute conditional and then followed by an optional else, which is named the alternative. And that's where we put this. So we have to keep that grammar rule. Or I could incorporate that back into here. Actually, that's exactly what I'm going to do. I'm going to actually take this out of that rule and put it in place of this. There. I'm going to say, well, there's two of these then, right? If we don't have an else, then it's just a state, then it's just condition, right? Well, it's statement. And it's not mutable. What do you think about this? Actually, it'd be cleaner to leverage that rule. So let me undo. Yeah, it's easier to leverage this rule, right? So then it's just condition, or actually this is statement, right? Statement. Statement. It would be statement dot alternative equals alternative. I think this is it. So why is that in red though? I don't know. I don't know why that's in red. Oh, because this doesn't have a bracket in front. There we go. Okay, so a statement can be a conditional statement with an optional else on the end, and we glue that optional else there. A conditional statement, we can build it up. So it can start with an if, in which case we have one alternative. And here's where also we initialize the otherwise to be, actually, it's not alternative, it's otherwise. Yeah. Actually, was this gonna work? Because this says it's any kind of statement. No, actually, this isn't gonna work. So the way I should do this is not a statement, it's a vector of conditionals. And we'll form this here, actually. So this is the conditionals. Oh, this is the alternatives. Yeah, this is right, I think. We'll have alternative conditional statements followed by an optional otherwise, and then we can just do this. Can completely shorten this. It looks nice and clean now, doesn't it? So the alternatives comes from a conditional statement, where if it's an if, we just initialize it to be a vector with one conditional in it. If it's an existing conditional statement and if we have an else if, then we're taking that chain and we're pushing onto it another conditional. Then when we finally reduce it with, we might have an else, in which case that's the otherwise, which we glue onto the end. That's perfect. Let's see if that shouldn't break anything. Right? Oh, no, we have grammar rule. Unexpected token on line 44. There? Oh, that's just supposed to be an equal. Okay. I had an arrow there where it should have just been equal. It didn't like that there. Expected one of 7 possible tokens. Am I getting too loose in my syntax here? What did I not like about that? It's like it parsed that as Rust rather than as a rule. Oh, because I don't have a comma there. That'd be why. Missing a comma right there, and so it kind of glued that to the end of my Rust code. Another place where I have something that shouldn't be there. Mutt chain. Another comma missing. Hope everyone is having a great Saturday. I'm having fun. Eventually I should stop for lunch though. Oh, I'm being rated by Anthony Writes Code. As I paused to say, I hope you're having a great Saturday. And look at that, I got a raid. I should be saying, I hope you're having a great Saturday more often. Then I get more raids, right? I hope you had a great stream. I'm working on a compiler for a data analysis tool, porting it to Rust from C. And we're passing all of our tests, which means our grammar's correct. So I just added this grammar for if, else chain. We're writing this using a crate called Lollerpop, which I will link in the chat. So it's a parser generator framework in Rust. You basically describe the grammar of a language using sort of a mix of Rust and BNR, Bacchus Norform. So like here, for example, a statement is what we're going to reduce some grammar from a bunch of symbols. And there are 3 alternative symbol chains that can reduce to a statement. There's the part, the ignore, and the conditional. And I was working on the conditional just now. Yeah, so the way Lollerpop works is you describe it in like a mix between BNR and Rust, and at build time, it finds it and generates a bunch of Rust code. And it's actually quite scary. So with just a single line, it ends up generating a file that's friggin' huge under target, debug, build. Never know which one of these to look at. I guess it doesn't really matter. Just I open them until I find it. Here we go. Look at this file. It is 120 something, 123,000 lines long. It's all of the parser generator constructed by Lollerpop. So it's a huge state machine. In fact, there's a big piece of it right there. Just this table of state numbers and then input symbols and then output state numbers. You can't read it. But that's what actually gets compiled by the Rust compiler. This, what we're looking at, is like the input to generate the Rust code. Didn't see the external Lollerpop file? Yeah, I fool people by using an extension that understands Lollerpop syntax. Lollerpop syntax highlight, which you can tell that it's a very niche thing because there's so few downloads of it. And there are basically no alternatives to it. Yeah, so the reason why I'm making a compiler, to back up a little bit, is 5 years ago I made a tool that I just used to play around with different data formats. And what you can do is you can describe the format of something. So for example, we're using GIF, and It's in a domain-specific language. So it's a language that I came up with that's kind of similar to what some file formats use in their specifications. So it's like a C function, but it also describes a structure, if that makes sense. So like a GIF file starts with a header, ends with a trailer, and in the middle there's like data blocks. But it's not only a structure, it's also kind of like a function because we have while loops and we have conditionals. And the way it works is, given like the raw bytes to a file, it will walk through the structure in order and match up the bytes to the parts that you specify. So it'll say, okay, a GIF, go into header, and then into header, we have this part specification. So it's a statement saying that we're going to have a string. It's going to be named signature, and it's going to be 24 bits long. So when you actually run the tool, it'll say, yeah, okay, from bytes 0, not including 3, trying to highlight it without scrolling, from 0 up till but not including 3, I guess what it is it's starting at byte 0 and it's 3 bytes long. We have the GIF's header signature, and that's the value of it. And then the next part, so we do a check, and we would error out if it's not GIF. Otherwise, the next bits are a string named version, 24 bits long, and we do a check on that. There we go. And then we escape out of header, and we go into logical screen, and then logical screen starts with a logical screen descriptor, and then that starts with an LEUI16, which is a user-defined type again, and it's going to be named logical screen width. So that is near the bottom of the file here, which says the next thing is an unsigned integer named LSB. It's 8 bits long, and then MSB, and then we're going to synthesize a value for LEUI16 by taking the MSB, shifting the left 8, and adding the LSB. So that's what all of this here is doing. So it parses 8 bits, 44, and then a 1, and then it shifts the 1 left 8, which is 256, adds 44 to it, and we get 300. So it's basically doing what a binary editor would do if I click there, and it says like, if it's, how do I show that? If I hide this, if it's little endian right here, then the next 16 bits is 300. So my tool is doing the same thing as this binary hex editor here is doing. So yeah, I wrote it all in a C 5 years ago and been porting it to Rust. That's what we're doing. Hey there, not that noob. Way to raid right after Anthony. So we have 2 raids. Hopefully you got most of the recap that I started describing to Anthony Writes Codes, guys. Yeah. So this the tool has its own domain-specific language that I've been talking about. That means that the tool has to compile that to something that it can use in memory to walk through data, right? So 2/3 of my tool is a compiler. So the first part of a compiler is a lexer, and I'll show you what the output of the lexer looks like. So given this program, the tokens that comprise it are, there's an identifier, a brace, another identifier, etc., right? So this is like the token stream. So we identify both the kind of token that it is and also where it is in the original file, so that if later there's a syntax error, we can say, well, unexpected token here, it's at line number 5 from columns 4 through 18, counting from 0. So in a pretty print, we'd probably add 1 to these numbers, so it would be line 6, column 5. So that's exactly right here, right? Line 6, column 5. And we'd say column 5 through 19. So that's all of this would be that token that we parsed out. So that's the lexer. The lexer, I used a different crate for. I have to open the file called token to show you that. Yes, here it is. So we used a crate called logos. It defines a bunch of macros. The biggest one is the derive macro for logos. Generates a lexer for this kind of token that we attach it to. So basically put a bunch of attributes that tell the generated logos lexer how to turn input character strings into tokens. So we identify all of our reserved words with the token macro. And for like non-tokens, like numbers, we have a regex, and we have to have a callback because logos will only like match the input character string. We still have to convert it. So we have a function to do that. So we get the slice of characters that it matched, and we tell Rust to parse it. And then we, if it's a parse error, it becomes none. I could have turned it into an error if I wanted, but I didn't want to do that. That's more work, and I'm lazy. So base 10 is easy, base 8 is easy, base 16 is harder because in Rust you don't have the X character. It's not expected for this function, but in my regex I had that. So I have like this X here. We have to like take it out before we can parse it. But you get the idea, right? This it's all I had to do was just annotate this data structure with all of the patterns to match, and then it converts it to a token string. Second part of the compiler is you turn that token string into an abstract syntax tree using a bunch of grammatical rules. So that's where we were when you guys rated me. So within the grammar, there's the concept of a list of statements, and a statement can be a part. And again, a part would be something like header, saying that that's a part of the file, right? That's why I called it part. And then we have a way to just say, like, if we put a minus in front, it means to ignore some bits. And then we have conditional statements, like if, else, if, else. So that's what I was working on right now. Similar to like Lex and Jack. Yeah. So when I wrote this 5 years ago, the Lexer, I used flex, F-L-E-X. And that would be the format.l. So it's similar to Logos, but more old school. It's just a list of patterns followed by what C code to inject that will return the value for that token, right? So reserved words are pretty easy. Here are those same regular expressions, and then we have to use some like internal variables of the Lexer and like attach the integer value to it. So it's a little bit more more boilerplate. But you can see it's kind of doing the same thing. We're using str to ll instead of parse because it's C instead of Rust. So use flex for that, and for the grammar I used Bison, which is a GNU version of Yak. And it's pretty similar to how we do it in Lollipop, because it still uses that BNF, Bacchus-Nor form of expressing the grammar. And whenever we match a rule, we say like what code should be run in order to reduce those tokens down into the symbol that we reduce it to. So we're doing the same thing here, right? We have some code here. The cool thing about Lollipop and Rust in general is that these reduction rules are actually really concise. Whereas before with Bison, you had to do all this setup because C doesn't have built-in vectors. I used linked lists, and so I had like next and last pointers, and I had to like manage my own linked lists and junk like that. I also had to do my own memory management, so we had to create a statement, and then we had to remember to destroy it later. Big mess, right? So modern languages, you don't have to call the constructor, you just make something, and then it gets freed automatically when it goes out of scope. It's great. Got it, kind of? Okay. At least you got it a little bit. So this syntax is a little weird when you first look at it, but basically these are the symbols that if we see that pattern, that sequence, it'll trigger the reduction of those symbols to one less terminal symbol, like a higher order symbol. When it sees this, it's going to say, aha, that can be reduced to be a conditional statement whose value is a vector of conditionals, and build that vector by running this code. And you can see it's recursive. So a conditional statement starts with an if and has a condition and has statements, right? This might make more sense, right? Literally if, left parentheses, some expression, right parentheses, left brace, some statements, and then right brace, reduces to a vector with one thing in it, so it's one conditional. And then if we have an else if after that, it takes that previous if and pushes another conditional onto the end. And then that repeats, right? Until we can't reduce it anymore as a conditional statement. And then we get up to here where we have that huge chain of if, else if, else if, else if, etc. And we might have a terminating else on the end, and that just attaches that otherwise to the alternatives. So in the end, we get the data structure in memory, the abstract syntax tree, and these are the kinds of statements we can have. And the ones we're just looking at were the conditional. The alternatives have all the if parts, and the otherwise has the else part. So you can see it's actually a recursive structure, right? Statement can have a vector of statements inside it, which is what you would expect for this kind of a language where you have like statements, and then one of these statements can be a conditional, which has more statements inside. So it's recursive. Losing my place. Here we are. These conditionals are what you might expect. It's the condition, which is the expression we evaluate. If it's true, then we execute the statements in the conditional. Otherwise, the semantics is that you would go through the alternatives, and the first one that the condition's true, you would execute. And if you fall through all the alternatives, you go through the otherwise, if there is any. Hopefully that makes sense. So the in-memory representation of an if-else chain, we're just holding on to the essentials. The list of conditionals, and then the list of statements either in the else, or if we actually match a condition, then the statements that we run for those things. And yeah, perfect timing rating me, because I'm passing all 93 of my unit tests. I've been trying to create a meta DSL. Do you have any experience with that? You mean like a DSL to describe itself? The only experience I have is Lollipop has its own meta DSL. I might have closed the tab for that though. Oh, here it is. So there's Lollipop's meta DSL. It's it can parse itself, because you can see, like, you use the word grammar, and actually here's the description of itself. So that token grammar is actually up here. So this is a grammar able to parse itself. I think that's what you meant by meta DSL, right? So yeah, the only experience I've had is I walked through this and I'm like, that's pretty cool. It's a syntax that describes itself. Yeah. So let me give you that link if you want to read through it more. Lollipop's meta DSL. All right. And it makes sense, right? If you had to make a DSL for making a DSL, then it should be self-descriptive. Compare the complexity between Bison and Lollipop. I was going to do that eventually, and I was going to do it just by timing how long it takes to parse a file in microseconds and see which one's faster. I'm fully expecting the Rust one will win. But, you know, I could be surprised, because Bison was optimized over many years. Even though it's old, it doesn't mean it's slow. Oh, I think a meta DSL will be a lot more complex, because a DSL by itself could be pretty simple. Like, this is a pretty simple language, really. That meta DSL, it has to describe itself, and to be a useful language, it has to have a lot of kinds of syntax. So yeah, this goes for hundreds and hundreds of lines. 521 lines. I would say that's a lot more complex than a typical DSL, which is maybe only a couple hundred lines. And when you think about it, there's really no such thing as a regular DSL, because DSL stands for domain-specific language. So it depends on your domain, right? If your domain demands a complex language, it's going to look a lot different than a domain that only needs like a very simple language. It's how you describe those features of a meta DSL, what makes it good versus bad. Well, in my mind, it's just a property of a DSL. If it can describe itself, it's a meta DSL, right? But that's not really the important purpose of a DSL. The important purpose of a DSL is to actually be useful in a domain. And something that is self-describing doesn't seem to be inherently useful. It's more of like a quirk. You want to get to meet a lot of people on this topic? Anything meta means it's self-inspecting, like navel gazing. And I've always thought about that kind of thing as really not intrinsically useful. Do you consider Swagger a DSL? I don't know what Swagger is. Should I look that up? What is Swagger? Swagger is an open term, so I need to have another term to close it, right? Like language. Let's see, what is Swagger? Allows you to describe the structure of APIs so that machines can read them. Oh, that's cool. Ability of APIs to describe their own structure. Yeah, do we have like an example? Like, yeah, I always dislike it when like there's no example at the very top. Because I'm like impatient. I just want to see an example. Example? Here we go. Beginner's Guide to Swagger. I want to see an example. I'm not seeing an example. Not good. I just want to see it. Show it to me. There we go. Finally. Sure, allow all the cookies. Yeah, I guess. This looks like a DSL. It's like it's very focused to API descriptions, right? Maybe there's a meta example or meta example DSL. Well, once something is meta, you formed a circle, and so meta is just being redundant, like redundantly descriptive. You're entering the web. Yeah, so what makes a language a DSL, I mean, is basically it is not general purpose. So in that sense, that there are very few true DSLs, because for a language to be a DSL, it has to not be usable as a general purpose language. And as Anthony Wright's code has proven to me over the years, you can make languages general purpose pretty easily. Like, I didn't know that SQL could be used in a general purpose way, and he demonstrated that with the advent of code. And so SQL, I might have said at one point, was a DSL. Now I no longer believe that. I thought it was EU only. I don't know what that means. Oh, do American sites also have cookie thing? Yeah, and it's modeled after the EU. A lot of American sites have the cookie site. Well, because they figure that you might be in Europe, and if they don't conform to the, I forget what the acronym is, the rules for privacy, then they could be breaking European laws, and then they could be sued in Europe. GDPR, thank you. Yeah, a lot of sites will just assume the worst and say you might be able to sue them if they don't protect your privacy. It's also not just in Europe now. Like some states in the United States have similar laws. Like I think California has pretty restrictive laws now about privacy. Want to see the keyboard? Made this on stream. The firmware is all in Rust. We coded that last year. That was last year's project. It sold last year. Okay, so I had just finished conditional statements. I like how I wrote this too, because statement says that we have a conditional statement, otherwise we have an else. Conditional statement is very nice because there's one rule for if and then another rule for else if, and then optional else truly is optional, or it's an else. I mean, it's optional in that you could have nothing or you can have an else. And the types are really nice too. Else doesn't have a condition anymore. It's unconditional, but you might have nothing. And then conditional statement is the conditionals, and then those become the alternatives of a conditional statement. Actually, then this isn't really conditional statements, is it? Let's rename that. This is more like conditional. Conditionals. Yeah. Yeah, that makes more sense to me. So renaming that shouldn't be any impact on our tests at all. You wrote all the firmware? Not all of it. That would be crazy because that would mean that I wrote the USB stack, I wrote the kernel and all that. And I didn't write all of it, but I did base. I basically I wrote the fact that it's a keyboard on top of a base of like microcontroller support code. So here's where I started. What I started with. I don't think I have a command for it anymore. Maybe I do. Let's see. Do I have an RP2040? I do. And then I have do I have what is it? I forget what it is. RP Rust RP2040. Yeah, so this is the base I started with. It was RP HAL. Rust support for Raspberry Silicon controller. So I started with that, and then I wrote all of the code that told the microcontroller that it was a keyboard. Can you use Lollipop to parse different languages like Python? Sure, I think so. Especially Java, because I've heard Java is pretty easy to write the grammar for. It's not for specific languages. It's for whatever language you can describe in its grammar. So I'm making my own language with Lollipop. I'm sure you could, if you wrote the grammar for Java in Lollipop, you could probably have it parse Java. What kind of switches did you use on it? The kind that let me pull them off and show you. These are the, what are they called? I need to actually hold it in front of the camera. These are hot swappable brown, what do they call these things? It's been a year, I forget things. Hot swappable, the word escapes me. Cherry brown, right, Cherry MX brown. Hot swappable Cherry MX brown. A friend of mine made his own keyboard based off of the Korn, and he has the low profile, can't remember the name of it, but he's got the low profile keys, which I think his is pretty cool. I didn't go that way because I didn't trust my own soldering skills. Cherry MX is a very approachable switch for a beginner, and it's easy to try. Like I could have changed them to blues to make them clicky keys if I wanted to, or I can just stick with the browns, which are nice and have a nice tactile feel, but don't have the loud noise. I have been starting to get some more bouncing on it, and I think it's just because the quality of my soldering. Have you tried Topre switches? No. What are those? Again, we're talking about last year's project, so not. I'm thinking I might not look into it, but I would at least like to know what it is. What's a Topre switch? They're hard to find them. They're an urban legend. Huh. No, I've never heard of these before. Purple switch? What? Always coming up with new colors. I don't know what they mean. Cool. Ones that HHKB uses. Copy link. Pasty link. Yeah, but that's the keycap. I want to see the switch underneath. Electrostatic capacitive. Wow, interesting. There's no like breakdown of it, because that's showing us the cap, but what's switch like underneath? I like to see what things are made out of. The copper springs that push down on the PCB traces. Oh, that's cool. So there's no what do you call them? There's no like it's been too long. I forget this stuff. The switch plugs. It's what the switch plugs into. Socket. There's no socket. It just touches the PCB directly. That's cool. Wouldn't that wear out your PCB though? You eventually get wear and tear on those with those springs on the traces. I found that the traces on the PCB I had printed are pretty sensitive, and just a little bit of heat will um, cause corrosion and also like actually strip away the little bit of copper that's there. All right, I'm gonna continue on while we talk and make sure that I got all of the conditionals. So did I get everything in this statement then? An if statement? I think I did. So we're moving on from if statement. Maybe we'll do the for loop next. Or the while loop is easier. Why don't we start with that? So it's while some expression in parentheses. So it's kind of like an if, only it's a while. So then it's just statements and a loop condition. So then I will have another structure, but it can be built into the statement. Why don't we add that now? So that would be a while. Actually, we might be able to reduce that to just loop, right? Did I do that in the original grammar? I did. So it's a loop with no loop variable or loop next. Just substatements and argument. It's different enough not having this that I think I'll have, in the Rust version, I'll have two of them. So we'll have a while and we'll have a for. So we have the, what did I call it? Condition? Or I call it argument? Loop condition. Loop while condition expression. And then statements, right? Actually, while we're at it, why don't we just add the for loop here too? Oh, you have a link of what it looks like? Hold on, we have two links to look at. Oh, I clicked the wrong thing. Close that. There we go. That wasn't... Oh, I know. I keep doing this. I keep opening it in another window on the host and not on the VM. Oh, cool. Okay, so yeah, that's what I imagined. So there's a spring directly on top of the PCB, so you don't need to have a socket. But it's not hot swappable. I really like the fact that I can do this to the keyboard. I can like, it's hard to show this because the table's not tall enough. But yeah, I can just kind of do that and I pull a key right off and it doesn't break anything. I don't know why I like that so much. Maybe the people that I show it to that don't know much about keyboards are like, oh, did you just break your keyboard? I'm like, yes, let me show you how to fix it. And I plug it back in. So where's the capacitive part? Oh, there's a capacitive sensor above the spring. Oh, I see. So it's like the proximity between the sensor and then something at the top of the spring, I guess. Okay, that's cool. And then that other link. Keycap, and then the plunger, and then there's the spring at the bottom. Okay, that's neat. Do they feel nice? The rubber dome pushes down. So that's the part that the sensor detects. So the spring is just there to push it back up then? The rubber dome is what the capacitive sensor detects? I take it. You like it? Cool. It's not hot swappable though. Just saying. For us hot swappable nerds, I don't know if that'd be that great. So a for loop has to have a loop variable, which is an identifier. And it has to have a loop init, which is an expression. It's two things. And then it has to have a loop condition, which we already have. And then we have to have a loop next. So loop variable. So we have an identifier, an expression, and a statement. Okay, I can do this. Identifier, so that's loop var is a string. That's how we encode identifiers. And then loop, it's already like a fish, my memory is. I've already lost it. Loop condition, which we have. Loop init, that's what it was, loop init. Does it have to be a statement? Oh, no, it's an expression. It's like a built-in kind of a statement. Okay, so that's loop init is an expression. And then the statement was the loop next, right? So why don't I just put all these at the front? That's a statement. Cool. Am I doing AOC this year? Yeah, sure am. Who is this data disintegrator? Hey there, Oblivioner. How are you doing? Yeah, that starts in December. I deleted my bot command for that. I should probably add it back. You all know what advent of code is, right? Advent of code. If you don't, then let me tell you, it's an advent calendar, which means there's one per day in the month of December. I clicked something. Of small programming puzzles, variety of skill sets that can be solved in any programming language you like. For me, that's Rust, or maybe Zig, or something new. I don't know. So that means like during the month of December, hopefully, part of my stream at least will be solving that day's puzzles. So there's like generally like a 2-parter puzzle, and yeah, we'll be doing that in December. Just released the 2023 page. That's what we were looking at, right? Yeah, we were just looking at it. December 1st at midnight, EST, UTC -5. So what does that mean for me? 9 o'clock at night? I won't be able to do it every night on time. In fact, what I'll probably end up doing is I'll be doing the puzzle the morning after. So I won't be competing on time, but I'll try to keep up and stay on track. I won't be competitive. It's been a tradition for you since the start of college. It's an awesome tradition. Do you pick a new language every year, or do you generally pick the same language? Or do you actually try to have every puzzle solved with a different language? Because that would be truly epic. Especially for the problems that are intended to build off each other. You'd be like, oh crap, I have the solution for that, but it's in a different language. Now I have to port it. Variable. I'm wondering if these names are enough for me to remember. I think so. I don't like the repetition though. I'm wondering if like this should be a composite, and this could be like this inside there. Because that's sort of what a for loop is. It's sort of a composite of a while loop and then some statements around it. I could have something called a loop, and then a while would have a loop in it. So just playing around here, we could have a public struct loop. Lopo? Who's that? And the loop has statements and a condition in it, and then the while just reduces to like a new type around that loop. And then I would do this instead. Oh, we can't call that loop. Body, I guess. Or I don't know what to call it. How about we insist in calling it loop, which means we have to do an R thing in front of it. If you really want to call something a reserved word in Rust, you can. You just have to put r hash in front. Try to get on the leaderboard. I can never get on the leaderboard. I'm too slow. I talk and I think too much as I'm doing it. Rust is not really the best language to get on the leaderboard, I think. I think you want to pick something like you're saying, like Python. Something quick, fast prototyping. So is that better than what I had before? It just reduces the redundancy, right? We're still going to have to treat these as different variants anyway, which means we'll have different matches. There's really no reason to do this other than it saves some of the redundancy. So maybe I just don't do it. Because then I have one fewer name at the cost of a little bit of redundancy. So there's some redundancy, but I didn't have to have that name called loop. What's the leaderboard based off size? It's based off of time. Size would be really hard because the challenge says you can use any language and you have to submit the answer. So they basically take the time which you answered and subtract that from midnight Eastern time, and that's your time. So it's not the time your program takes to run, it's the time it takes you to post the answer to the puzzle. And that's actually a good I should actually say, in addition to that, that's the people that get on the leaderboards with the smallest times, I think they do so by doing some prep work beforehand and trying to guess what class or category of problem it'll be. So this is how I would do it. If I wanted to game the system, and I would look at all the past advent of code puzzles, and I would say, okay, there are roughly 20 different categories of puzzle. There's like a path searching problem. There's a numerical analysis problem. Maybe there's a prime number problem. So then I would code up or select, like from previous solutions, like an exemplar for every class or category of problem. And then I have them all in front of me. And then I would, as quickly as possible, right at midnight, I would try to say, like, the first objective would be like, what category of problem is it? Oh, this one's a prime number one. Then I would just like go straight to the prime number example, and I would say, what do I have to change here to meet the specifics of the problem? And then I try to do that as fast as possible, get the answer, and post it. And that's how some of these people get like insane times, like 10 seconds, 15 seconds. It's not possible for me to get that without having typed most of the program in advance. And there's no way to know to do that unless you have some guesses as to at least what kind of problem it's going to be. Closest you've gotten is 204. Is that as in 204 seconds? That's still pretty fast, right? That's less than 3 minutes. So, oh no, less than 4 minutes. So 3.5 minutes. So I type slow, especially on this keyboard that some idiot made. I'd never be able to use this keyboard and actually get on any kind of speed leaderboard. Okay, there's the AST stuff we need. So, we have a problem, right? This is an infinite structure unless I box this statement here. Everyone know why? Why did I have to box that? Because a statement, if it were to have a statement in it directly, causes a recursion that makes the size of the structure infinite. What box does is makes it a pointer to a statement on the heap. So that's the equivalent of in C if I did this. Right? That is a box statement. This whole line becomes this. Without the box, it's like we took that asterisk away, and it is there in memory as part of the parent, which is impossible if it's recursive. But if we make it indirection through a box, a type can have a pointer to itself. A type can have a pointer to another instance of itself because the size of a pointer is always fixed to be like 4 or 8 or whatever, and has nothing to do with the size of the thing you're pointing at. Another interesting side note I like to make, especially because it's nearby, a box and a vector are pretty much the same thing, except for vector allows you to have 0 of it and more than 1 of it if you want. A box is always 1 and only 1. It's like a non-nullable pointer. Do you use the keyboard for work too? Yes, I do. Get faster on it in a few months. For me, it was like slow plateau and maybe even like falling a little bit on the end as I like swap between that and another kind of keyboard like a QWERTY. Not a 36 key, but a full keyboard. I'm not like a competitor when it comes to keyboards. If you watch me type, you'll see me make tons of mistakes. Plateau of despair. Yeah, well, I try not to. I try like to see the positives of it. So I'm not going to despair, but yeah, my speed is plateaued on this keyboard pretty much. And when I run the keyboard tests, if I like really relax and go with the flow, I can get maybe 90 words per minute. But if I'm under pressure or I'm doing lots of programming and symbols, it's way lower and with much higher error rate. Okay, let's make a prototype test for a loop. I'm actually thinking we can just steal like from if. Yeah, what if I steal this? These test cases are actually pretty long now, aren't they? Because we're getting into the higher order constructs. Okay, this will be a while loop. Actually, what if we just say while loop? Okay, so we'll have a while, and then here's our condition, right? And then there's our statement. So that's actually fortunate. And if and a while are very close. So instead of conditional, we should have a while. And the while has a condition, which is a single conditional. Whoa. Wild cursor swings. Back. Whoa. Fill struct fields. How come? Okay. Condition, conditional. I already had a condition, conditional. It's not understanding me. I need statements. That's what I need. Oh, I see. It's just that. And then that gets outdented. I'm slow today. I am slow. Why is that? Okay, it just took a time to compile it. So while 42 bar. Well, that looks right to me. Just run this and see if it works. No, I don't have any syntax for it. It's going to say it doesn't understand while. Unrecognized token, while. Okay, time. So we did the test first. So I'm getting back to my roots, so to speak. What I did when I first was streaming. I'm doing test-driven development. I wrote the test first. Now it's time to write the code. So statement. We have a while. And then we need the parenthesis condition. Actually, it's pretty much that, right? Left brace statements, right brace, and then it's not a vector. We get a statement while condition statements, right? So this part, that's it, right? I just did it. Except for we don't have while in our list at the bottom. See, I make mistakes like that because on my keyboard I don't have a dedicated shift key. So if I want to type a capital W, I have to hold down N and then hit W. But if I hit it too fast, it becomes lowercase nw. You have this thing, if you think about the fact that typing I'm super slow, but when I'm doing it super fast, there's a term for that. I don't know what it is, but I remember reading about it. It's something to do with motor memory, like muscle memory. That if you're mindful of it, it's gonna slow you down. But if you let your muscle memory take over your motor function, you clear the way for it to more efficiently replay learned behavior. So all you need to do is think ahead. What you do is you consciously think ahead of what you want to write next, and then you kind of give it to the automatic part of your brain to translate that into the muscle movements, and you leave it alone to do the typing, and you just if you're mindful of what the next thing you're going to type, but you're not there yet. If that's what you keep your brain focused on, you streamline your typing. Problem I have with that is if I haven't trained my muscle memory, or if I need to retrain it because I'm hitting the wrong key all the time, I stumble and fall, and I have to hit backspace, and I have to consciously say, how do I type a W again? Okay, it's that. And my finger slipped, so I have to remember. I have to see that, and then it slows me down. Yeah, you make typos if you haven't trained your muscle memory, which is easier said than done. While loop. Boomer. Does that still work? No, I don't have that command anymore. I used to have when someone would type in chat boomer, I would have a picture of Boomer from Battlestar Galactica. Boomer. There you go. There's Boomer. That's a double joke. You'd have to be a boomer to remember the original Battlestar Galactica's Boomer. Okay, I must have a syntax error here somewhere in the grammar file. Oh, yeah, it's the comma. Commas are important. Yay, we passed. So while loops work. How about for loops? Go to our tests, and we'll make a for loop instead of a while loop. Comma chameleon. By the way, I made a mistake 5 years ago when I designed this language. Maybe you can spot it if I show you the old grammar. So for places where I have op comma, a lot of them work just fine. But let me show you one where it's sort of weird. Oh, maybe it was where comma is. Not op comma. Oh, it was expression list. That's where it was. Yeah. Do you see the problem with this grammar? This allows me to do an expression list starting with a comma and then an expression, because this is allowed to match the empty rule. So it lets me get away with really goofy things like where I have like here, we have a function, like we have arguments to a grammar, we have arguments to a format. I can actually put a comma there and it's valid. Now, this is not valid. The bug is that the way I wrote the grammar, the comma comes before and not after. That's comma chameleon. It's that comma that might be there or might not, right? I think it has to do with the fact that I have 3 rules and not 2. So you can have a single expression, so there's no comma at all. And then this was intended if you have 2 or more expressions, but then I forgot that this could match a single, but it also could match empty. That's one of the things that I should probably in my to-do list track. So actually, before I forget again, let's add that to the to-do. To-do. Fix the comma before grammar issue. There. Now I won't forget, right? Okay, so this one is going to be a for loop. So instead of while, we have for. And then we have a bit more tokens to put in here, right? So that is the condition. We need the loop var, loop init, and we need the loop next, right? So the loop var would be like an identifier like, well, we have to use I because that's the traditional loop variable, right? And then the init would be token assign or equal. No, it's assign, right? I actually have a token called assign, if I remember right. Assign. And then some value, right? Let's go ahead and make that 0. And then we're supposed to have a semicolon, I think. And then the condition, and then another semicolon. And then the loop next, which would be like, what? I equals I plus 1. That's long. How did I do this in here? Oh, we can do a decrement thing. Oh, we don't have the syntax for that yet, though. Well, that'll be interesting. I guess we'll add the syntax for that as we go. I could just put something bogus in there. So what would be something bogus? Actually, I'm not going to do that. I'm going to do the increment. So that would be token increment. Is it inker? Plus plus. Where are you? Inc. And then that identifier again. And then did I have to have a semicolon? I think I did because the statement syntax requires it. That was another thing I wanted to fix, actually. The fact that I have to put a semicolon there is sort of weird, right? Hi there, Katoli. I'm working on the grammar for our language that I made for describing data. That has to have token in front. So this is the unit test for how to recognize a for loop in my language. So for left parentheses, we have I equals 0 semicolon. This is bogus though. Oh, we should make it realistic. Like I is less than 10 or something, right? Equals 0. Plus plus I. There we go. For I equals 0, I less than 10, plus plus I, and then the parentheses, brace, and then we have the statement. Okay, so then we have a for loop. we need these things added to condition and statements. Okay, so the string, that was this I. Expression is a less than. No, it's I put that under binary operation, right? I can't remember these things. You know, too many things to remember. It is binary operation. I knew it. The what's going on with my mouse? Yeah, binary operation. It has the left-hand side, and it has an op, and it has a right-hand side. Left-hand side was it's a reference, right? So expression reference. Op is binary operator less than. And right hand side is expression literal integer 10. So transiting semi for in a for loop. In mine there is just it's a limitation of the grammar. Because statement always ends in either a semicolon or an interpretation. Here it's because I'm reusing the statement grammar, it has to end in a semicolon. So that's thank you for reminding me. I want to make that a to-do. So this should be like enhanced grammar to not require semicolon for the loop next statement in a for loop. Loot? No, loop. Yeah, so now we won't forget, right? Okay, so in a reference, that has to be a reference, right? Reference is a vector. So it's a vec with a reference part with an ID and indices. Okay, ID is I again. Indices, vector. Okay, and the expression is 0, right? Literal integer 0. For I equals this isn't right. That's the loop next. I got this is the wrong. This is the loop next. And wait. I'm getting this confused. A lot of this is the loop next. So let me copy what I had so far and put it in. So this should be box new, right? Yeah. I got confused. It happens. The loop init is just the expression is just the thing we initialize it to. So that's just this part of it. Yeah, that's it. I got super confused there. I got the init with the next confused. So it's just the equals is assumed. to be equal to that, and then we're going to box up a statement. And the statement is a decrement statement, which we don't have in the grammar yet, but I have the old rule for it. Let's find that. Or an increment statement, right? Yeah, increment attribute statement. So I don't have this yet, but let's pretend we do. So it's increment and then a reference and then a semi. So statement decrement. And let's just say, yeah, it has to be a reference, right? So there's where the reference thing comes in. And there is no indice to that. It's just that. And then delete that. Okay. Not sure I like all of that. Reminding me of Lisp again. Two, three. Yeah, I mean, it matches. We just don't have a decrement statement. I guess we'll just add it now. Here we go, dec. Or it was supposed to be increment, but we'll add both at the same time. Where was I? Where? Here, increment, right? Let's add increment and decrement. It's just increment a reference. Decrement a reference. There was no more to that, right? It's just increment and decrement. Oh, also return. And that's an expression. So just add it now. I need to remember that there's no test for these, actually. So I don't want to forget that. Okay, because while we're writing one test, I don't want to have to go stop and write another test. But I did want to make a realistic looking for loop. So for I initialized to 0, every time we increment I, we go until, that's just not right. Oh, I deleted it too. There was the less than expression, right? Yeah, we'll fix it. There's going to be a literal integer in there, but the outer is a binary operation. So that's like the right-hand side is this, but it was 10, right? Left-hand side is a reference expression. And the op is a binary operator less than. And then we're copying the same reference to there. Hey there, Ramy. Is Haskell good for parsing? I don't know. I don't know Haskell. I don't know no Haskell. This is Rust, not Haskell. Should I say like wowie? Because he's lurking without sound? Okay. This is a pretty complex thing, this for loop, isn't it? Okay, what am I missing? It doesn't like that parentheses there, but it should match there. Guess I could look and see what it thinks the error is. Unmatched delimiter. Unmatched brace. A brace missing somewhere. Oh, here it is. Right there, right? Okay, and then this is wrong because why? Oh, we need to box it. We need to box the expression. Hold on. Go back to the loop. Where is it? Box the whole statement. Okay. I did box the statement. So it's at the, is it the expression? Oh, we have to box both of them because they're both expression. Got it. Okay. Yeah. So we have to box these, this one and this one. Box, new, and then another level of parentheses there and there. Not declared. The quick action doesn't work, so I'm doing the workaround of letting that say use there. Ah, my goodness. So much work. Cool. Well, it finally works. Let's run it. Need another curly bracket? Yeah, I did. Yeah, it took a while. Thank you, Objective Allison. Or is it adjective? Adjective? Adjective. Adjective is one of those weird words where when you look at the spelling, you think it should be adjective, but it's really adjective, right? Yeah, so it doesn't recognize the for token yet because I haven't written the grammar rule for it. So let's do that now. And we got to go to grammar lollipop. We have to tell it what for means. For means the token for. Oh, while we're at it, let's add increment and decrement. Since we're here, right? Why not? Dec. Token dec. And why don't I ask, I'll just add return here while we're at it. Return. You can't pronounce it honestly? To use a well-known FMT file in your lecture to generate tests. Boom. That's what Sarian was trying to get me to do for the last few days. So the idea would be that you would memoize the output of the lexer and somehow like copy paste that back into the source code of the test. And I guess I could do that, but I don't know. I just get lazy and I'm like, I can just type this. I don't have a good reason. Okay, statement. Okay, here's where we add the for loop. L paren. So it's going to be loop var, which is an ID, and that is a terminal statement. A token. And then we're going to have a terminal assign. Actually, I don't have a sign, do I? Oh, it wasn't a sign, it was what was it? No, I don't even remember. It was a sign. Okay. That's right. So we need that. Assign. Okay. The grammar file is certainly getting respectably long. And then we have a loop init, which is an expression. Which means we have to have a semi. And then we'll go on to the next line. So this is the loop condition. So loop or condition, like here. Semi. And then we have the loop next, which is a statement. And semicolon is included in the statement. So then we end with our paren. And then we have the statements inside the loop. So that's a statement 4. And then if I did this correctly, I could just fill those things in, like loop var, loop init, loop next, condition statements. And it should just all work magically. Do you find your brain to be strange? It's the only brain I've ever known. Do you mean like that it acts strange sometimes? Certainly. Because I compare my actions with those of other people, and they do seem strange sometimes. Different is maybe a better word for it. But aren't we all different? Pass first try? Yes? No. It couldn't compile because there needs to be a box new on that. Oh, that's very helpful. It actually knows I need to box that. It's so helpful. It's like you need to box that. Indeed, I do. Why did it go and say that? Yeah, we still have errors. Missing loop next. Oh, because we have to actually name it. Actually, you know what I'll do? Is I'll just say let loop next equal loop next dot boxed. That's what we'll do. Your rephrasing of your question as well as rephrasing of your response are both delightful. I tried to turn the second person back to the first person and vice versa when I repeat it. Yeah. Well, it built, but it failed. Unrecognized token inc. Oh, right. We don't have the syntax rule for that. And one depends on the other, right? So what if we add the test for inc and then the grammar, and then we get the test to pass together? Because it shouldn't be that big a deal. So although I don't need most of it, I can start with a copy of the for loop just to get the increment statement out. Increment. All we really need is the statement that was in here somewhere. Loop next. I just need that. So I'm going to cut everything before that. And then cut everything after that. And then outdent it. Okay, and then it's just this part. Token increment I semi. I guess we need the delimiter for the vector. There we go. Missing something. I don't. Oh, I do see it. There we go. Expected and expression. Because of the comma. See, I can figure things out. So this, let's see, this won't work because we haven't written the grammar rule for it. But test-driven development says, make the test first, see that it fails. Then do the code change, see the test pass. Unrecognized token inc. Yeah, perfect. That's what I expected. So go to the grammar. Add an increment statement here. So that's increment reference, right? So R, I guess. Was it ref for reference? It's ref. Semi, right? No, semi is not part of it. Or no, it is. I need to clean this up. Yeah, it's part of it because I wanted some statements not to end in a semicolon. I can't put this in the outer grammar. That's right. Okay. Lame. I wanted to do item for that. So let's do it. It's actually maybe part of this. So why don't I just make that part of this as part of this? See if we can remove semi from all or most of the statement rules. There we go. Okay, so we have semi in a bunch of these rules that maybe we don't need to have, but we'll just go with it for now. So this is just statement inc r. Okay, and then go back to the tests, run increment test. Starting to feel those the lag in the Rust compiler, and the lollipop builder actually is also slow, right? Okay, that passed, so then my for loop will pass, right? Of course it will, because we have full confidence. 96 tests passed. Okay. Since we're right there, why don't we go ahead and add the decrement and the return, and then I can get rid of those 3 to-dos that I added. So we have increment, and then we have decrement, and then we have return statement. So this is return, and I can make this simpler because we're allowed to return literals like integer 42, right? So that's a return statement. And this is supposed to be an expression. But we can make it just a literal integer expression. 42. What am I missing here? Nothing. It just took a while. Okay, so this is decrement. Okay, this will fail because we haven't added the grammar rule for it yet. Build, 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 build. Done. So we should have 2 failed tests. Yep. Decrement return statement, right? So then go to grammar. I thought that I should just do it right now because these should be like really simple. Because they look like increment. Like decrement, super easy. The only thing about increment that's different is it's not a reference, it's an expression. Right? But the form is very close. Just remember, an expression can be a reference, but it can also be a literal. When you increment and decrement, they have to be references. So a reference is like a subset of an expression. Almost to 100 tests. Oh my goodness. Oh my god. Okay, so format. Oh, break was like... Wait, how come it's just break? I don't allow any values? Right, because I don't actually assign meaning to statement groups yet, like Rust does. So it's just break. Actually, these are the only 2 left. Why don't we just add them now? They're very much like return, right? In fact, break is even simpler. So this is like a break statement. It's just break. There is no integer. There is no value. Just break. And then error statement. That does have an expression. Right? Okay, I'm gonna get set up to fix the grammar as soon as that's done and it tells me I have 2 failures. Oh, actually I have to add it to the AST. Yep. So we did these. We have break and we have error expression. Okay, and then 2 failures, right? We need the word error here. Token error. Yep, it's what I expected. I had so much confidence that I started modifying the code without even waiting to see it. That's how confident I was. Break. That will make it not pass yet. We have to actually add the rule at the top. So very similar to return, right? So this is break, and this is error, and there's no expression for break. $100 tests. It should be exactly 100. Woohoo! 100 tests. I want some heavy metal background. Maybe a double thumbs up for the fireworks. There we go. Okay. Those fireworks actually last quite a while, don't they? I could also do a heart. Right? There we go. Hearts. Silly. And if I don't like what I see, I do the thumbs down. Double thumbs down is like clouds or something, right? Yeah, it's like raining. It rains on me. I do a double thumbs down. Okay, I'm pretty much done with statements, right? I don't have accumulation. That's a plus equal, right? You know, I have accum, which is plus equal, I think, but I don't have minus equal or times equal or any of that. I wonder why I never did that. Yeah, see, I have plus equal, but I don't have minus equal or times equal or divide equals. I think I just added that because I needed it for something. What if I like leave that out for now? I think I'm going to leave it out for now. Sleep well, Dr. Padawan. Is it that time of night for you? It's the middle of the day for me. I gotta stop for lunch at some point, though. So I think I'm gonna skip the attribute assignment. No, I need that. It was attribute accumulation. Oh, this had special meaning. We could extend a vector. So maybe we do want it then. That's why I had it, because I had a use case where I want to just add to a vector. So I guess maybe we'll add these together. So we have assignment and then we have accumulation assignment, which is special for a vector. And we are missing local and we're missing the bounded region. Okay, so we have bounded region, local, and then we have these. Let's do the 2 assignment ones right now. So let's just add them here, I guess. So this is like assignment. So I need a reference. References are kind of hard because there's a lot of overhead for a reference in the way I'm doing it right now. Statement assignment. Yeah, so what I was thinking of doing is this. So we have like the L value or reference, I guess, is that, and then the actually, why don't we just do left-hand side, right-hand side? So that's token identifier, this thing. Token identifier. We already had token in our clipboard, so we didn't need to do that. And now I'm getting off track. There we go. Token assign. And then 42 and then semi. Okay. We don't have assignment yet, but we'll have that soon. Accumulate, right? So that instead of assign, it's accumulate. Right. So then for this to build, statement has to have those two things in it. Assign. Left-hand side is a reference. Right-hand side is an expression. And then accumulate is also like an assignment. Okay. Accumulate. Assignment. So I guess I have been making the words complete here. So I should probably call this increment decrement. Can do that easily with the refactoring tool. Okay. Oop. Except for the refactoring tool, it doesn't go into the grammar file and fix it there. It's up to me to do that part. All right, now let us make the test pass. So left-hand side reference, assign, right-hand side expression, semi, right? Gives me a statement, assignment. I'll get it eventually, right? Left-hand side, right-hand side. And then accumulate symbol gives me accumulate. Oh, we have a new leader for the first token. Yeah, I should stop for lunch. Hold on a second. I need to stop for lunch though. So I actually haven't been streaming around meal times lately, and I'm not sure what to do about, like, do I stop the stream and eat and then start it again, or do I stop it for the rest of the day? No, I'm still going. I just haven't decided, like, is there a lunch break, or do I stop and then stream tomorrow, or just stream later? I need to reach a good stopping point first. Sorry to unlurk you, just to say thanks for the stream when I'm still going. I didn't mean to do that, sorry. So I did that, all of that, right? What was the last thing? Yeah, I swear, it wasn't an unlurk technique. I didn't intend to unlark you. It was assign and accumulate that I did, right? Okay, and then I just don't want to miss something here. That's assign, that's accumulate. I did increment, decrement, return, break, I did all that. I did error. So what am I missing? I'm missing local attribute declaration, and I'm missing bounded region. Okay, how about I'll do these, and then we'll be done with statements. Be done taking statements from the audience. Just kidding. I'll eat after I do these two bound. So the easy one first, locals, and then identifier, and then semicolon, and that's a local statement with identifier. So we'll have a local in here. Identifier, right? Which is a string in the AST. Local string. And then, actually, while I'm at it, why don't I just add the other one too? So that's an expression and then a bunch of statements. And that's a bounded, that's a bounds, really. It's this bounded statement. The bounds has a bound, which is an expression, and it has statements, just like a while loop. So the way the bounds works, I use that to skip the compressed data in a GIF for now. It's sort of just a trick. It's also a double check. So down here where we actually have the data sub blocks, they're compressed. So rather than like decompressing the LZW stream, we just said, well, right before the block is the number of bytes. So then we skip that number of bits by having no data consumption statements, but putting inside of a bounded block makes it skip that number of bits, right? The idea is that we might skip it and then come back and do a second pass parsing by going back to that point in the bitstream and like collecting these things we skipped. But it also lets me do this trick where we just skip it. So that's what a bounds is. And then local is just declaring a local variable. Okay, then test next. These are all scrambled up, aren't they? Yeah. That's okay. The tests don't need to have any sort of order. Token, local. And then identifier and then a semicolon, right? Could put that all in the same line. So that should give me a local statement with this, with just this string. Super easy. Local. Okay, and then the other one was a bounds. A little bit more complicated because we have a bound, which can be any expression. So let's just keep something simple. Expression, literal integer, 42. And then the statements. I'm inclined to just keep it an empty thing, but let's put one statement in there. Actually, let's have a statement called error or something like that. Something easy. So this thing, because we can, right? So that means it's left bracket, and then we have our literal, then right bracket, and then token left brace, token error, token, let's make this number different, 67. This, like that. brace. So left bracket number, right bracket, then left brace error. I think we have to have a semi. It won't let me get away with that without doing that. Make this a little bit easier to read, and we're done. Looks good to me. So this is not a local anymore. This is a bounds. Okay, make sure that compiles. It will fail the test though. So here, is local in our list? It is not. Look at that, it did exactly what I thought it would do. It's like I read the future. Okay, and then local statement here. So that's local. Name is IED. Semi reduces to statement local name. And then the other one's a bounded region, right? So that's left break it. And then bound, which is an expression. And then R bracket left brace. And then statements. What did I name it in this? Just named it statements, okay. R brace. R brace. Okay, it's too long, so let me we break it right here. So this becomes a statement bounds. Can't spell. Bound and statement. That's it. Time to eat, right? 67 instead of 42, you're probably right. But I have another problem. It's statements. So if you're right, I fail my test because I have the number wrong. Yeah, it's gonna say that it got something different than what we expected. Yep. See, that's what it will show if I get the number wrong. You were faster than my computer to tell me that that was wrong. And I swear that was not a unlurk technique. First time chatter, Casencio. 104 test passed? Yes. Cool. Let me back this up. So send that out of the virtual machine. So it's backed up. And I think that's it for at least a while. I need to take a break. I need to eat. I want to make sure, did I get all kinds of statements in my language? Yes, I have part, I have ignore, I have if, for loop, while, bounded region, local attribute, assignment, accumulation, increment, decrement, return, break, error. I did it all. All of this is done. So what's to be done? I did all this. References are done. Key values is done. Expression list is done. Expression is done. I did all kinds of expressions, right? We have binary operations. We got is a member of. I did flip and minus, right? And I can't remember if I did. So that would be somewhere in the expression tiers. I'm looking in the wrong place. Somewhere in the expression tiers, I should have a flip. Flip, flip, flip. Probably at the bottom, right? Yeah, flip, not, and minus. Okay, we did them all. Okay. Flip, minus, and not. We did the grouping, we did function call. I did intentionally remove the construction expressions. So we have maps, sets, and vectors, but I didn't do the construction ones because I don't think I actually need that. I didn't do the copy. Did I do attribute lookup? I hope I did. Yes, attribute lookup. Literals did nil, right? Nil is nil. Good. I think I've done everything except maybe handling of bad strings and syntax errors. So the only thing really left to do is to build off a statement, which would be format. I only have format left. Wow. So I only have one syntactical construction left. Well, I have that and then I have the top level. So I guess next, that's what I'll do. Maybe after lunch, I'll just come back and whenever the next stream is, I'll do format and then formats, which is the top level. And then I'll be able to actually show the abstract syntax tree. And then we move on to stage 3 for the tool, which is to do the actual data analysis. We use the abstract syntax tree to walk through data. And that's going to be all new Rust code, not leveraging this lollipop. It makes me think that before I eat lunch, I should actually do these last formats, and then we have a clean break between the parser and the analysis. So maybe I'll keep going, but I do need to take a quick break. I'll be right back. Oh, I'm back. At this rate, lunch is going to turn into dinner. It's 2 o'clock. It'll be a late lunch. I don't know. I actually don't even know what I have to eat. Hey there, Mr. Couture. I'm almost done porting a compiler to Rust. And I only have a couple more grammar rules left. So we have format and we have formats. So I think this deserves a new test file. So, yeah, let's copy statement to format. Who's that? It's a kitty. We have a kitty. She's like, pay me attention. I want some attention. Okay, so format. So I'll need to have that added to my tests here. Mod format. Cool. Thank you for the cute cat comment. She's a real bundle of cat for sure. Where am I? How come the tab doesn't show? That was weird. Okay, I think what I'm gonna do is pick a minimal statement and wrap it up into a format. Yeah, so statement parser becomes format parser. Okay, and then actually we can leverage that. So the format, let's say it's foo. I don't even need these comments because it's going to be pretty straightforward, right? It's going to be, we need to have one without arguments and then one with, because that's what the grammar calls for. We have optional ID list, statements. Yeah, so let's do that. Formats. This will be one without. So L paren. No, L bracket. And then I want to leverage brace, right? I want to leverage where was it? Yeah, like this stuff. I just want to copy this. I want to copy that and paste it up here. And that's all I need. I don't need any of that. I don't need the parentheses. In fact, yeah, so just an identifier, a brace, and then some part. So that would be format. Gotta think. A format is going to have statements, but it's also going to have an optional argument list. So that means really the format has two things. It has args. In this case, it'll be empty. And it has statements. In this case, it'll be not empty. Actually, then don't I want to test with no statements in it too, right? That's the most trivial format, is a completely empty format. I'll do that in a second. So the statement part, didn't I have something simpler? Yeah, here we go. The simplest kind of statement. Simplest statement goes there. End vector, end format, and this is one statement. Okay, and then let's make an even simpler one with no statements. So empty vector, because we have nothing between the braces. Okay, yeah, I know format doesn't exist yet. It will exist as a format. Okay, we're almost there. We're almost done. Let's have one with an argument. So copy this. Call this with an argument. So instead of, well, in addition to the brace, we have token L paren, token R paren, and in between we'll have something like token. This has to be an identifier list, right? So this has to be an identifier bar to string. Okay, so then the arguments, it should just be the names. There we go. That's it. Delete everything else. So test. Oh, it said statement body. That's actually not the right name for it. It should just be test statement. Okay, so this is test format. Use a format parser. Okay, cool. So this won't actually work until I make a format and a format parser. So let's do the format first. The same level as like statement, we'll just add another thing called format. The rs, so for the lib, we have mod format. Would it be possible to use this tool another way around as generate output just based on some input data? Yeah. Although I'd have to extend the grammar to allow it to emit output. Right now, the grammar doesn't actually generate anything. It is completely introspective. Like, It just tells you what you gave it, but it can't generate something output from that. So I've done that kind of work before where you make a compiler that makes an AST that contains like directives to generate something else. Well, I might do that eventually on this project, so stay tuned. So like one possible purpose of this tool might be to take a GIF that has multiple images in it, like the one we've been looking at, right? This, and maybe generate individual image files, one for each frame. We could do that. It wouldn't be too hard. We would just need to isolate the individual frames and then write them as separate files. So if my grammar allowed us to like have emit or generate statements, we could do that. We could totally do that. But I have to think about the top level syntax, right? Because right now it's geared towards just describing the data, not doing anything with it, right? So like if you look at gif.format, it's just a bunch of format descriptions. There's no like you would want some kind of like maybe list of commands you could do, like output frame n, and then something would have to call it. So there's no concept of a main program in my language. The closest to that is you identify which is the top level format. So you go into GIF. But see, all it really does is describes what's in the GIF. It doesn't have any like what do you do with it afterwards. For example, modify slightly, increase or decrease the rate. So I got to think about that because I don't know if I'd want that to be part of the language overall, or maybe that's something on top of this parser. Like after we parse the GIF and we get to this abstract data tree, then maybe something else goes and modifies that, and then maybe we have the inverse of this. We would generate the output bytes from the structure in memory. So those are all great ideas and things that I want to look into, but they're right now beyond the scope of what the tool does today. I need to first get it ported to Rust, add a nice GUI to it, and then that's where I think we're going to think about what can we do with this now that we can look at data. We can think about maybe we can modify it. Maybe we can generate something new from it. Okay, format. I can steal a bit from statement, right? Because we know we need this boilerplate up front. We just want to call it a format. And it's not an enum, it's a struct. And it's going to have in it its name, which is a string, and its arguments, which is a vector of strings, and it's going to have its statements. It's a vector of statement. The only thing it doesn't know about is statement, so we can import that. All right, and then back to the test. Arguments. We can afford to spell that all out, right? And I forgot the name in there. Probably you were watching me earlier and thinking, why doesn't he actually use foo? And that's because I forgot. I forgot that the name has to actually be stored in the format, right? Now it makes sense. So the same thing here. In fact, why don't I just copy the whole line? Did something wrong there. What did I do? Oh, probably because the expected is the wrong type. That's down at the bottom, right? We say what the expected is. Yeah, it should be format. Okay. Why doesn't it like that? Field is private. Let's fix that. These should all be public. Go back, save again. Now that's all good, right? Okay, so we're just missing the parser. Parser is generated by the grammar, so let's make the grammar at the very top where it belongs. Pub format gives us a format, which equals... I'm actually kind of growing fond of describing these grammars, so it's name, which is an identifier, and then there's an arguments, which is an oh, actually, now that I think about it, it's not optional, is it? It's just ID list. Hold on, let me think about this. ID list doesn't actually have parentheses in it. So we do want op ID list, but we want to strip the option away from it, right? Oh, this is another one of those option vec. We don't need option vec, right? Yeah, so let's look ahead and say that we actually expect it to be a vector, but we're going to use optional ID list. And then L brace, and then statements. R brace. A little bit too long, so we're going to go to the next line and kind of indent this. Right, so we get a format whose name has a name, an arguments, and a statements. There we go. Hi, Edzark, how are you doing? You started programming. Really nice to see me working. My voice is really relaxing. Well, thank you very much. I appreciate that. Always like to listen to programmers while they think. Yeah, so if I wasn't streaming, all of the words coming out of my mouth would instead be just stuck in my head. I still think all those things. It's just I'm attaching it to mouth when I'm streaming. And I do that on purpose so that you can get a sense for if you're learning how to program, you're learning how to think about design, that that I'm an example of what you might be thinking as if you are typing this stuff, right? Not to say it's the only or the best way to think about stuff while you're working, but it's just how I work. Name is an ID. Yeah, so we need to fix this op ID list. Oh, that's the only place I use it? Okay, good. I won't break anything by doing this. So basically option vector is sort of silly because a vector allows you to have 0 things in it, and then option lets you have none, and those things sort of mean the same thing. Nothing and an empty vector kind of mean the same thing here, right? So we can collapse these two to just be a vector of strings, and then the old rule that says there's nothing, we can just say that's an empty vector, and then if there's something, then we just carry that vector from ID list. Easy. And that even allows us to have empty parentheses also mean the same as no parentheses at all. Which I should have a test for now that I think about it. So let's add a test for that. So we have no statements and then we have one statement. So we should have like no statements and then we should have like a no arguments, right? Where we intentionally have like, this can be all in the same line. Why not? I'm going to intentionally have an empty set of parentheses. Here. Up. Here. No, not there. Here. So. This should give me the same thing as if we didn't have the parentheses. Yep, I'm almost done resurrecting the parser part of the tool. So I'm done, right? I should just be able to run these tests. I did the grammar. Yeah, I think we're ready. If this works, then the last step is to just have a format chain. Nope, it doesn't know what format means. Because we never imported it. Let's do that now. Format. Format. Run it again. Okay, yeah, I guess I did have a test for op ID list, so we need to fix that. Here it is. And it's the type is wrong, right? It's just vec. Which means all of our tests, like, there's no sum anymore. It's just a vector with foobar in it. And this one, still an error, still an error, still an error. Okay, in this, there's just an empty vector. Makes me think I should have a test where there's empty parentheses, right? So this is like empty ID list. So that should go to an empty vector. We can collapse all these, right? No need to keep all the new lines. Yes, Kitty, I'll give you some attention soon. You want to go on camera again? No? She's like, I want your attention. Oh, shoot. So all the errors have to have... I'm not sure where that was. Where was that? I'm not seeing the errors. Oh, it's in the grammar. Okay, yeah. Yeah, in the grammar for ID list, right? Op ID list. Oh no, I fixed that. Oh, no, I fixed that. What's there? Format not found. That was a previous run, right? Yeah. Oh, it just worked. There was no error. It passed. Okay. 109 tests pass. So the very last syntax is to be able to chain together these formats, right? It's this rule with maybe this if we need it, but I'm not sure we do. I'm not sure we need a formal rule to declare an illegal terminal. I think we just stop, right? And we just say that there's an error. So I just need this one last rule then, and let's just put it into, do I have to put it into, yeah, I have to put it into its own unit test. So where we had format, we'll have a formats here. Take that, copy, paste, make it formats. Go up a level into tests and make mod formats. Okay, and then in formats, we have, instead of format parser, it's formats parser. Okay, so we can have like, actually, let's just do the completely trivial case. No input at all. Should match an empty hash map, right? Hash map new. Because my idea was we're going to make a hash map from format name to format. No formats. And then the case where, as I hope that we can do hash map if they're equatable. They might not be equatable, but we'll see if they are. So yeah, the expected output is the result of a hash map from string to format. I hope that that's equatable if we import it from collections. Seems okay. Okay. So we have no formats and then we have like one format. And I don't need to test stuff like this, right? So I can just leave that off. And then I can say that this is a hash map, mash map or hash map. Wasn't there a macro that we could like leverage when testing for this? Hash map macro. Common macros. That wasn't it. What was it? Maplet. That's what it was. Maplet. Maplets on version 1, is that right? Like maplet as in literal maps, right? Yeah, it's on 1.0, so we can just leverage that in our testing. So the way we do that is in our cargo toml, under dev dependencies, we list maplet. 1.0, right? Yeah. Then I can, here I can actually do a map literal. So I do what they had. Where was it here? Hash map bang. Hash map bang. And then I use equals greater than for the arrow. Okay. So foo goes to that. Fighting my editor, by the way. So fun. I have to use, I think this is old style. We don't have to say that anymore. I think all we need to do is say use maplet, right? Hash map. That's the new syntax, right? Yes, and then it's okay with it. That's just format. Okay, cool. So then let's have a, oh, it didn't like it. String. Oh, that has to be to string. That did it. Okay, cool. Let's delete the other tests. This is test formats. And then let's have a test case for two formats. Two formats. So that's easy. We just duplicate this. We have foo and we have bar. And we have foo and we have bar. Okay, so we don't need statement. We just need the actual parser, which we make from the grammar. So let's make the parser. So formats is going to be a hash map from string to format. And this is the top level syntax of my language. So we have the empty rule, which goes to hash map new. And then we have the left associative rule, which is mutable map is formats. And then we have another format, which is next, I guess. Did I get that right? So this one gives us map dot insert next dot name dot clone next map. Work first try? Very, very low confidence it'll work the first try. What are my opinions on DSLs defined in Atlas? I don't have an opinion because I don't know Atlas. Okay, I have this collection import we need in the parser generator. Too many tabs open. Way too many. Okay, hopefully that fixes it. This is going to be a late lunch, but it'll be nice in that we'll have the parser completely done, which it is now. Look at that, all 112 tests passed. Sweet. For icing on the cake, let's write the equivalent of what I had in C++, which was I had a parse format, which generated a report which showed like all of the formats alphabetically sorted, and it like would print all of the information about them. I guess it doesn't need to be as pretty as this, but we kind of want to at least to spend a little bit of time. I want to have a front end that's like parse format, so we'll call it parse because the other one was called lex, right? Parser done 100 tests, 112 actually. So what's the error here? What's going on? Oh, I never hit save on that, so it never reparsed it. But that doesn't affect our tests, right? So yeah, we had lexer and then we made it lex. So parser, we should have something called parse, right? Parse. So at the top level cargo, we're gonna have parse. And Rest Analyzer hates me now because I didn't put a cargo toml in parse. I'm just gonna copy what I had for lex. Copy and paste. Run that again. It's not gonna like it because I didn't name it right. Too many windows open. Okay, this is called parse. And it's using the lexer and the parser, right? Yeah. Along with clap and anyhow. Okay. Hey there, Mr. Balrog. Lexer, lex L? Yeah, basically. Or parse, or P? Would it be par? I don't know. Parse seems like it's a verb, right? And like lex is a verb. Like lex that, parse that. What OS is this? It is Xubuntu on a Parallels VM on a Mac Studio, which lets me do this if I want. Look at that. Or if I want to make it rain. Make it rain. There we go. Okay, so the Lex read everything in and lexed it. So we still want that, right? But we're not going to do this anymore. We're going to feed it to a parser. It is pretty dope, isn't it? Okay, so how do we use this parser? It was in formats that we did this, right? Yes, so we just did this because it works with okay, it needs to be a vector. I thought it could take an iterator though. Why did we need to collect? Why do we need to collect that? I forget why. Let's see if it'll take an iterator. So, then I don't need to fold, do I? Yeah, this we're actually not doing anymore. Let's keep it around though. We're gonna do one of these. So, let parser equal formats parser new, and then we're gonna say parser.parse from the lexer. And we're getting out formats from this, right? Import. I should have been able to do that. So I have to do. Oh, wait, hold on. I don't have a front end to the library. I don't want to expose the internal grammar. I want to have a front end to the library. So that would look like parser new. That would just be parser new, right? And we would like do something that use parser. And I suppose there's where I would let it borrow the lexer, right? So this type doesn't exist yet. We want to put it at the top of parser. In here. Okay, here's where we're going to do the parser. So pub struct parser impl parser. If I could type, we would be able to say pub function new. We want a lexer here, right? Lexer. We're going to return self. Okay, and inside here is where we're going to make one of these parsers, right? Actually, parse is going to return a formats. So that's a hash map string to format. And there's where we fill in what I had in the other file. This thing. Yeah, so it's going to be a result. But I want to wrap the error. I don't want to expose the internal error type. What was that internal error type anyway? Yes, please type the commands from my bot. Let my bot be useful. Here, I think, right? Formats parser new. Yes, so there's a parse error. Do I want to expose that or no? I could just cheat for now and just have it return an anyhow error. I don't really want it to expose the parse error type. Where's parse error actually? Is that in the top level tests? Yeah, I don't want to have to expose that type. You've gone through all the commands, yes. There are even some secret commands that you haven't guessed. What's the error here? Unresolved import. Because I didn't import it? No, I have parser. Because I have an error in parser, probably. Yeah, because I haven't finished this yet. Let's just have an error type for now. We'll just have it be empty. So we can get an error. And we'll just do a map error here. It won't be able to help me until I get some of these types defined. Import lexer, that's right. And then hash map import from collections and import format. And we need a parse. So technically I don't need to store anything in the parser, right? I could just make one at this point. So that's what I'm going to do. Oh, you guessed lollipop. There you go. You found one. You found it. Or did one of my other commands mention it? No, I think you found it. You figured it out. Okay, cool. So actually, this is exactly what I want, right? I'm hoping it takes an iterator. Otherwise, I'll be crying sad crocodile tears. We just have to import format parser, which it doesn't have any idea what it is. Because we have to teach it that. So I can just say use grammar format parser, right? Yeah, okay. Mismatch types. Yeah, I need to map the error. Map. Don't know what to do with the error yet, but we'll just make a new error that's empty. That's what I was afraid of. Okay, it's because we don't have input, because I actually haven't provided the input. The input's what again? Vector of tokens. Oh, right. So here's where I gotta glue things together. The parser should be independent of the lexer, right? So the input, so it really should be that we parse something that provides us tokens. So this should be generic off of some, yeah, we shouldn't be tied to a particular lexer instance, right? Let me think about this. So we are tied to the lexer type, fundamentally. No, we're not. We're only tied to the token type. We're not tied to the lexer type at all. So it's the token is defined in the lexer, but we're not tied to the lexer itself. We don't actually care, right? Yeah, the token type's exposed by the lexer, and there's this convenience for the lexer. Actually, do I want to use it? I don't know. It's revealed in today. Ah, there we go. I'm kind of indecisive about what I want to do here. You make a lexer by passing the input, so really this should be let me think about this. Does the parser need state? It shouldn't, right? So maybe I just keep the struct thinking that it might have state in callbacks or something later. It's not going to though, is it? Okay, well, one thing I can look at is there's too many things open. Close. How we use this thing is it does seem to have state because there's a new, but the parse is where we give the input. So I should just follow the same convention, right? I should have the lexer be given to parse, and then it's parse given the lexers into iter, right? Oh, this should be formats parser. The type, that type was a giveaway. It's working. Oh, oh. It accepts into iter, so I don't need to say that. It's probably going to tell me new is unneeded, but that's okay. Consider having a default. Okay, we can do that. Generate, no. Generate a default dimple. Look at that. It just does it. It's sweet. That's it, right? So go to parse. The bin or whatever it is it bin? The main. I don't have it open. I'm lost. Too many things open. Close everything. Okay. Parse, source, main. Here we are. Here we are. We're in main. We should be able to get a parser. Why can't we? It's defined multiple times. Ooh, yes. Okay. We can make this one go away, though. No, I can't. What if I do it as clap parser and then derive clap parser? Is it gonna let me do that? I guess it did. Okay, cool. So then, given the program to parse, right. So we move that to here, right? Functions must have a self. I don't see the problem. I thought I called it parse. Why are you not letting me call it? Parse. Oh, I didn't have a self on there, that's why. Mutable self, I suppose. Hold on a sec. So, is this mutable? I don't think it is, right? We can't look at it here. Can I look at it? I don't know. I don't know how to find that function. Yeah, clap is a command line argument parser. Command line argument parser. Wait, what? Oh, yeah, we can't do that. It has to be mappable. It has to implement standard error. So I can fix that. So impl standard error for error. Wait, what's the error here? Doesn't implement display trait. Okay, please derive display. Oh, you can't derive display? Okay, fine, we'll have to implement display. So that's standard format display for error. I know what I should be using. I should be using the crate that is used to make custom error types. I just can't remember what it's called. Wait a minute. It has to implement debug? That's derivable. Right, this has members we have to implement, so it's like we can just do nothing here, right? Write something. Write parser error. We have to write it to F. And it's we don't need the semicolon. We want to forward the error from the write macro on. I actually wanted to print literal curly braces there. Now we're good. So let's just see if it actually runs. Terminal cargo run. Instead of lex, it's parse. Hey, it ran. Neat. So let's have it print out like for format in formats. Let's have it print line. Format dot name. Oh wait, that is a string and so it's like name and format. And we don't need the format yet. So it's just name, right? There we go. Yep, so it parsed all my formats. There we go. And let's have it say something more about it. So let's have it print out how many statements there are. So that would be, there we actually need the format. Format.statements.length. So now we can start doing cool things with it. There we go. We have a statement count for every format. The DataDisintegrator is the language you're defining in Lollipop, so you can define how to read binary first. Yeah, you got it. So I'll show you what I had for the C version of the code was right here. So given here's what it. Well, how come it's not showing it? Because it's JIT, not GIF. There we go. Here's how you describe a format. So I hate it when the tick is missing. It's this X that I want. Okay, so if you describe a format in my language, it's like has a dual nature. It looks like a structure, and it defines a GIF file structurally. It begins with a header and ends with a trailer, and there's some data blocks in the middle. But it also works like a function. As we're parsing a GIF, we're going to parse the header first. Then we can have loops and conditionals, which control the interpretation of the bits as we're reading them in. So only if the next 8 bits is not a 3B is it a data block. Otherwise, it's a trailer block, right? And we can also use conditionals to detect errors. So the signature has to start with GIF. So when I show you the actual file, not how we would see it, but how the computer would see it, like that. Indeed, the first 3 characters is GIF. Next 3 after this 89A, and the next 2 bytes after that is 300 for the width. So that's how far I got in the C version of this tool. I wanted to port it to Rust, and then I want to add some cool scripting and UI to it. So something similar to this, you could consider the data dissectors in Wireshark, right? Given like a packet that you captured off of your network card, here are the raw bytes of that packet, and here's an interpretation of those bytes, what it means. If the tool has a dissector for the different protocol layers, then you can click on a different piece of the packet and it'll show you which bytes it maps to. Another example we ran into was the 010 editor. So Strager has written syntax for the 010 editor for some files that he deals with, and I haven't actually tried this editor, but from what I can tell, it's like a smart binary editor where if you tell it the format of the bytes and what they mean, it will kind of highlight like a language server might highlight, only instead of it being code, it's binary. So I'm trying to build up tools like that, and it is an excuse to practice Rust. The language, I had to make a language to be able to describe formats in a generic way, because I don't just want to make a GIF file parser. I want to make a parser that is programmable. So I had to invent a language that is like suitable for describing binary data, and this is what I came up with. But yeah, it is mostly an excuse to practice Rust. So our compiler now can, it has it all in memory, and I kind of wanted to get it close to what the C-based parse format did. So it would have like reproduce the format by printing the format, and then I think after the parentheses, it could print the arguments. Yeah, see, like it can print the arguments, and then it would print the statements like recursively. So I think I want to try to do that. This is the ultimate network viewing and hacking tool. Not so much hacking, but mostly viewing. Yep. It's not open source. I've been meaning to make a command for the bot to say this, but there are 3 rules for me to stream while working my current job. It said I can't talk about what I do for work. I can't do open source, and I can't do game development. So it's closed source for now until that changes. So yeah, I don't need to print this stuff, right? We don't really care about the locations of things. We're going to print the format first. So let's get that out of the way. We're printing the name, right? In fact, I can build that into that, like so. And then we say if format dot arguments dot, it's not empty, then we want to print parentheses, and then we're going to print something, right? Well, actually, we can break this. I know I'm doing it imperatively. I probably shouldn't do this. Do it imperatively, right? I should form this, put parentheses around it, and yeah, we'll do that. So the way we're going to do that is format.arguments. Fold, not fold. Thing is, how do we like add a comma after each one? Okay, I'm not going to think too hard about this. I'm just going to do it the easy way, which is that it's all imperative, and you guys are going to hate me, but that's the way it is. So it's like this, right? And then we have let mute first equals true. And then we have like for arg and format arguments. If first, if not first, print comma space, I guess. Maybe just comma. First equals false. Print it's just arg, right? Just strings. Let's try that. Yeah, there we go. Now we have the arguments in there. Okay, what was the next thing it did? Can I have keep referring back to the C version of this? Okay, so then it would break down the statements with pluses, and we're looking ahead. We're going to have a function that we can reuse that prints a bar and a space for all the levels up to it, and then prints a plus and a space. Okay, so that would be here, right? It would be print statements, level 0, and format dot. Actually, this goes inside here, doesn't it? Format dot statements borrowed. Okay, now we need that function. Function print statements. So it's level u size, I guess, and then statements is a borrowed statement. Import. I can't import that. Oh, it's hidden from me. So that means in parser, I have to put a pub in front of all the things I want to re-export. Yeah. Shoot. Yeah, we want to do that, right? That's gonna be a pain in the ass. Pub use format. Why is that a problem? Define multiple times. Oh, because I already had that. Pub use. Statements. We'll just start with that. So now I can be able to import that from the parser. Cool. So then it's going to be for something in level print pipe space. And then print plus. And by the way, this is for statement and statements, right? Zero to level. Okay, why is it not? I have an error, that's why. There we go. For statements, so we want to print like, let's just print a debug version of the statement. How ugly could this be? This is probably going to be very ugly. Let's see what we get. Ooh, very ugly. So I guess what we want to do is we want to implement the, I guess the display trait, right? Because right now it's just printing out all that stuff. Also, the line breaks aren't right, so that should be a print line. It's a little bit better. We're getting there. Yeah, but the recursive stuff we aren't doing, right? So where does the recursive stuff come into play? It's when we have conditionals and ifs and all that stuff. Yeah, so this is going to take me too long and I'm hungry. So maybe I stop here and I just say that this is working. It's kind of gross right now. Oh, we should have like I was doing in the other tool, print a blank line between formats. So that would be like another blank line after the statements, right? Yeah, so now it's sort of coming together, kind of looks like the other tool. Only it just needs to be cleaned up. It's also not sorting them. Cool. All right, I'm gonna clean that up next time, probably either later today or tomorrow or Monday, and then actually start doing the data analysis stuff. Good thing you've been practicing encryption lately. I missed the context of that, I guess. You seriously look for something like this for months when you're reverse engineering an old unsupported 3D mesh format? Yeah, I've run across a few people that have like when they're reverse engineering binary formats, would have found something like this useful. I think there are things out there though. This 010 editor looked promising. There's also a couple other things mentioned by chat, and I don't remember what they were. I'm sure ChatGPT has lots of suggestions if you want to ask it. So I'm not making anything unique here. When I do something like that to decompose this, this using this, right? In fact, if I could put that over here, it might be kind of cool. We're decomposing this using this to get this. There's probably lots of tools out there that do this. I just happen to be making another one of them. Yep, time for me to go eat. Thank you guys for watching. Oh, Mr. Sir is going. Chris Griffin made the chat overlay above my head, and he's literally streaming all the time. The only time he's not streaming is when he's sleeping. He even streams when he eats now sometimes. So let's go say hi to Chris, all right? I'll see you guys later. Thanks for watching. Bye.